Fake GPS? That's like fake GPS or something like that?
The time.
Hey Sean, if this is your extra program, I'll ask for help later because we gotta. Okay, you guys ready?
That's the one who doesn't know how to play a violin.
I do play the violin.
I don't even know how to play the guitar. It took less than 2 years.
What's that?
Anyway, so
Oh, what's going
we're on case 1 now. So we left you guys. We finished case 1 with setting the run modes, run using encoders, and power 1. I can drive forward for 2,000 encoder counts, and then stopping. That's what you guys all have right now, correct? And does anyone not have that?
Raise your hand if you do not have that.
Yeah, you guys need to either answer yes or no, one way or the other.
I have a slightly
Because an awkward silence does not help.
Yeah, it's definitely awkward. Hence the name. So case 2 is going to be the third case that we have, starting at 0. In case 2, you're going to go ahead and put this. Now what this is the reset encoders code you're going to want to use for case 2. So the code for this will reset the encoders, and then this will force it again to wait until both encoders are equal to 0. Now this is a little bit different from the last bit of code that you had for waiting until the encoders are reset. But you are going to go ahead and use this one that's highlighted instead of the old one. You can leave the old one in, but for the case 2, put in this. And let me know when you guys have that. So who has case 2 done? Anybody have case 2 done? Alright, you guys? Alright, who does not have case 2 done? Alright, 3 people. I'll go help you guys with that first.
I just hate it.
Anybody need help? Or is this time? Okay.
I don't think you can see it.
Done.
Alright, everyone have that done now? Anybody not have it done? Alright. I'll give you guys 1 more minute. Alright, everybody got it now? Alright. Alright, so you got case 2 done. Now what case 3 here is going to do, it's a little bit longer, but there's a bit of a reason for that. This one is going to actually have the robot turn instead of going forward now. What we got to do is we got to put in the set direction again because the motors are going to be turning separate directions. And one of them is going to be turning a different direction from its original way of turning. originally left front was set to forward and right front was set to backward. But here you're gonna have both of them set to forward. That way, when you give it power, it will do a left turn. So you can go ahead and do this. And then I'm again checking the left motor. Oh, sorry, it's gonna do a right turn, my bad. But either way, this code will do that turn. And I'm checking the left front for its encoder value, because that's the one that will be going forward this turn.
And one thing to point out here, in this particular program, we're setting the power to 0 each time. You probably don't really want to do that in your competition, because what you would do is you would go straight and then stop, turn and then stop, straight and then stop. So you probably don't want to actually stop each time. You would get very jerky. You want a smooth motion, right? You want to go straight from moving straight to turning. So in a competition program, you would probably not want to have these and just say, if the current position, increment state. What would that do? It would increment to the next state, and then the next time through the loop, it would just automatically go on to the next movement behavior. So, I mean, you can put a stop in there for testing it now, but you'll probably find in competition that you don't want to necessarily stop each time.
Is this for attendance?
I guess.
Oh. This seems very complicated.
Yeah, it's going to be an autonomous that will drive forward, then turn, then drive forward again. But the good thing is, once you kind of get the main part of this down, you know, where then you set to 0 again and have state plus plus, you can pretty much just copy and paste this basically to any of the other states that you want. For example, what I have here for case 4, which I just set the motor direction again because I just did a turn. But then when you see this here, the set mode, reset encoders, this if, here in case 4 is exactly the same as what was in case 2. So a lot of the code is going to be similar between the different cases. So if you want, you can go ahead and do case 4, where you just add in the left front set direction forward and right front set direction reverse, and then copy and paste down here all of case 2.
I just mean like it wasn't a minus or negative. Letters are one plus 2 forward, one negative. It's so much easier to translate this information. No, it's not like programming.
Oh,
It's like, so you guys use 2000, right?
Yeah.
With your scale, so how'd you guys come up with the scale? Because we had trouble coming up with shit.
Well, I mean, you can do basically whatever you want for like the number of coder counts you want to go, but well, it just depends on how far you want to go. Like with the guys using the Tetrix motors with the encoders on those have it's like 1,140 counts per revolution or 1,440 counts per revolution, something like that. And then the HandyMark motors here that have an encoder built in on the back, it's like 1,120 counts per rotation. So we just figured out how many rotations we need to go based on the size.
you know what? He needs a copy of the PowerPoints from yesterday. There's basically what you can do is convert distance that you want to travel. Say you want to move 12 inches, convert that to circumference of your wheel and how many revolutions of the motor that means, which means how many ticks. So Joshua, would you go in the CAD room? I think there's a couple extra copies of the PowerPoints from yesterday. Could you go grab a couple of those? Ask Samuel Joel. I think they were sitting there on the table kind of near them. So we can give a copy to these two groups so they can have that.
All right, does everyone have case 4 done?
Almost.
Alrighty. while they're getting case 4 done, we actually did make a program that would take, like, you'd be able to input in the diameter of your wheel, the gear ratio, and then the number of inches you want to go, and then we calculate the encoder distance. And if you guys want, I can show you how I did that, like after we're done today. I can show you that method, and that's a pretty simple way to calculate it.
Yeah, I did something really different for autonomous. I just used the counters, and I made it turn, go forward, go forward.
Okay.
What's the advantage
Yeah, what's the
of over
advantage?
this, of what?
State machine, I'm not exactly sure, we're just showing you guys like 2 different ways to do autonomous. You can kind of choose which way you want to do it. But one advantage to the state machine is that, like, if you want to be returning telemetry to help troubleshoot, it works well in a state machine because it's already in a loop, whereas in a regular linear output, it only goes through once. You have to have things referenced to go down to telemetry in a loop. Yeah.
So, how would you program, like, I'm gonna assume you would use a state machine, but like, how would you program like the robot to like receive information and do something with that information?
Like from a sensor,
Yeah,
we're actually going to be discussing sensors right after we're done with this.
but wouldn't it be like, if this, and this is true, then do that, and that? If not,
Yeah.
then don't do that?
And what you can also do is, you can have, it'll return in different ways. The sensors are a little bit difficult to work with if you don't really know how to use them. But once you kind of know how to use them, they'll be returning numbers. Or the touch sensor will be returning, Boolean, true if it's pressed, false if it's not. But the others will be returning numbers. And then you can use, if the numbers are equal to such and such, then do this. But you can also just have it like direct input from the sensors into the motors. Like, this is a weird example, but if you have a distance sensor inputting the distance that it sees directly into the motor power, then it'll drive full power towards the wall and then slow down the closer it gets. But yeah, we'll be discussing that a bit more this afternoon.
Also, another thing is, would it be possible to like make one sensor just always be running in the background of your autonomous program?
Yeah, we're gonna start talking about sensors in a minute. Just you guys get state machines finished so we can move on and talk about sensors. Look at all the sensors.
All right, everyone have case 4 done? Everyone got it? You guys got it good? All right. That's basically like all you need for a really simple one. Is actually it just goes forward and then turns. But if you want, what you can do is in case 5 right here, if you want, you can actually copy this stuff from case 1 because it'll just go forward again. You don't have to do that, but you can if you like. But now might be a good time to go ahead and add this to the FCC outload register and download it onto your phone. So you can test it over here on our test board because our test board has encoders on it. So if you want to do that, now's the time to do that before we get to work on the sensors. Does anyone want to try it out on the test board? Anybody? Wes, I'm assuming by what you're doing, you're going to try it out, right? Okay. So one person trying it out. Anybody else?
I go with
Wes, you downloaded to this one. Wherever.
I'm not open that. So you just do, you just put case 5 right here.
Yeah, you can. Case 5, and you gotta have. Yeah, the colon.
But why is it over like that?
Because we're expecting. There we go. You were missing like a lot of things. So that means that, so the if is right there. Okay, so the other case,
copy from case one?
If you want to. I mean, you can just download it the way it is right now and it should work.
Okay.
Nick, could you go back to the,
Oh, yeah.
state machine?
This? This right here? There's an arrow.
Hey, Nick, is state machine all done?
Almost. There's still people working on it. Adding a little bit more in.
I don't need to try it, it's fine.
Okay. Are you guys gonna try it?
No.
Okay. Alright, I guess then we can go ahead and move on to sensors. I guess they are ready.
Okay, my turn.
Okay.
Okay, my turn.
But you are gonna be using this though today. You're using this now, right?
Yes, a little bit of that and a little bit of that, so. Okay. Would you, yeah, we'll-
Mark, you just think. Go ahead.
what I need is this program. Okay, so here's what I'm going to do. I'm handing out a couple of things to you guys. We'll go through it in a minute. Okay, Joshua, what you handing out to everybody? Yep, everybody gets one. Hopefully we have enough. Okay, so the first document that you are getting says modern robotics on it. This is a sensor document. You can download and print this one yourself from Modern Robotics, but I thought it'd be good to go ahead and print it and give it to you. So Sanjay copied it for you today. So as we go along, you can take notes in here if you want to. I am working under the assumption that most of you are going to be using Modern Robotics sensors. Is that an accurate statement? Is anybody else using sensors? Are you guys using sensors other than Modern Robotics? I'm sorry? You're using Modern Robotics? Okay.
I don't know yet. I guess we are.
Okay, I presume that was a safe assumption because they came in the base kit. So, let's talk about some of the other hardware stuff. In your base kit, everybody should have received 4 sensors.
We have one. From the basics.
Okay. Okay, this is what they call the core device interface. Okay, I'm gonna wait.
We're gonna put everything. Let's concentrate which one's missing.
Okay, is everybody paying attention?
Which?
I'm gonna show you in a minute. Okay, I'm gonna show you in a minute. Yep, I'm just waiting for you guys. Have a seat. Listen up, I'm about to go through that right now. Okay, have a seat. I'm about to show you what you should have. Okay, first thing, to be able to use the modern robotic sensors, you're going to need this device. It's called the Core Device Interface. It's got several kinds of connections. It's got I2C connections. A lot of your sensors, we'll go through in a minute. If the sensor has a really fat tip on it, like this one, compared to a skinny tip like this one, the fat tip is an I2C, the skinny tip is either analog or digital. So you can see you've got several ports on here. You probably won't need more than one of these, but you'll have to connect this just like you do with your other modules. You'll connect it up with one of these white wires, data wires, and that's all you'll need. Okay, in your base kit, everybody should have gotten 4 sensors, and I'll show you which 4 sensors they are. You should have gotten the touch, so it looks like that. Pretty obvious, it's got the little red button on it, okay? You should have also gotten this one, which they call an optical distance sensor. And if you look at the end, see the 2 little LEDs right there? That's how you know it's an optical. Yeah, don't plug it in yet, guys, just. Oh, okay. So you should have an optical distance sensor. And you should have also gotten an IR sensor. This one is kind of fat on top. I don't know how else to describe it, but that's your IR seeker. And then your last one is your color sensor. And the color sensor has got the LEDs on top, like that. So the base kit should have these 4. If you don't have a color sensor, I highly recommend you get one for this year, maybe a couple of them, and you'll learn why very soon. So these should be the 4 basics that everybody should get. And we're going to go through and I'm going to show you how to program all 4 of these today. Now another one worth considering is the gyro sensor, which looks like the touch sensor without the little red button. Oh, it's microscopic now. This is your gyro, okay? Nothing too exciting about it. This one did not come in the base kit. You have to order it separately. Highly recommend everybody get one of these. And the last one, this is a brand new one they just released this year, and they don't even have methods and classes created for this yet, is the range sensor. We just got ours, I haven't even opened it yet. Range sensor. So the range sensor is kind of nice because it's got, there it is, right on top. They've got, see the 2 LEDs? So it's basically a light sensor and ultrasonic all built in one. So the general idea here is your ultrasonic will get you from a distance, and then once you get closer, you can use your light sensor. So it's supposed to be a more accurate range estimation. Like I said, they don't have classes and methods for this one yet. You can still program it and use it, but you're not going to be able to use first classes and methods. You have to go straight to programming the I2C registers and all that yourself, which you can certainly do, and hopefully if we have time, I'll show you how to do that. Okay? So those are the basic sensors. Does anybody have any questions about the sensors before we start talking about programming them?
Right now, you can get.
Okay, what was your question?
Where do you guys get your sensors?
We bought them from Modern Robotics. When we bought our electronics kit last year, I thought it came with all 4 of these. Maybe I bought the color.
sensor is not included.
It's not. I thought it was, okay? All
But
right.
Modern Robotics has a bundle package for $99 right now, and it includes the color sensor, the new one that you just got,
The range.
and then the
Gyro?
other 2. The gyro is 4 sensors, because I just ordered that one and got it last week, and I didn't bring it, but yeah, so that. and
The
it's not-
bundle is
which
cheaper
is
than
good.
buying them individually,
Yeah.
so the bundle's a good deal.
Saves you about
The only
$20,
one
maybe
that's
$30.
color.
You want the gyro. Buy the bundle, it's cheaper. If you got some money, buy the bundle. Okay, all right, so, we're gonna do a combination of, oh, okay. Yeah, I don't want to zoom all the way in because when I turn the page, you can see the whole thing. Rick's in his sensor 3, but everybody look at him. So everybody gets one. Okay, we're gonna hand out these sensors so you guys can look at them. We will try to get some set up. We should be able to program and then test them on the push bots. So we'll need, actually what I'll ask is while I'm talking, I'll have Joshua and Nick, wherever he went, hook up the device interface modules to the 2 push bots so they can hook up the sensors. All right, so. Oh, okay, all right. Okay, so the second handout you should have is a program. And I'm going to take a minute and walk you through, oh great, how do I get back to Android Studio? Josh, do you know how to get back to Android Studio? Josh, how do I get back to Android Studio on the projector?
I think Nick said that the space bar was like transitioning or something.
No.
No, we changed that. Is OBS open on it? It should be a black circle
On the
with
white-
like
yeah.
30 little squiggles on it.
Go get me.
It should say source.
I was gonna say.
This has symbol, but I don't know which one will be source.
Is there a box with an arrow for the top?
Okay, we'll get Android Studio back up. I'm gonna show you guys, you do not have this program, so you're gonna have to type it from scratch. So what I did was I basically went through all of the samples that are in Android Studio, and I'll show you in a minute as soon as we can get it up again. There's all kinds of samples and examples that they have programmed and put in the basic SDK for you. They've got sample programs in there for using the color, the optical distance, the touch, the gyro, and the IR. Everything but the range is in there. So what I did was I took and cut and pasted pieces from those examples and pasted it into one. So I created one just for myself. And all this does is literally runs our sensors on the sensor board and displays the data on the phone. So this is just for the sake of today to show you how you would program to get the data off that sensor. Now for each one of them, when we get them programmed, and you actually see what kind of data you get back, we're going to have to talk about how to use that data, because just getting the data is one thing, but how to interpret it and apply it within your logic is a completely different story, right? So let's
Can you
just
say
get started.
which sensors you included in this?
We're going to go through as many as we have time to, but as a minimum, we're going to go through the touch, light, color, IR, gyro.
They're all in this program?
They're all in this one. Color, IR, optical, touch, gyro, yeah. Those are the 5 I want to go through. Okay. Okay, now the one I'm about to open, again, you guys don't have, you're going to have to type it in from scratch. How do I get the mouse on here? It's got the mouse on your screen. Okay, never mind.
The mouse isn't.
Yeah, I'll use it. basic SDK. So maybe just watch here, and then later you can go home and do the exploring, and then we're gonna create this file from scratch. But look over here on the left side, you see they have all these examples. I found some of the best examples to use started with PushBot. So let's go to say PushBot Auto Sensors. So I'm going to open that one. Now you guys don't have to actually do this, but remember how Nick was showing you if you wanted to look at the program beneath it, you touch Control and click and it opens it. So let's say I'm scrolling down through PushBot and I see, okay, you can see here within the loop, they create a state machine. They have a program here where they're resetting encoders, so they're using their own PushBot methods for drive using encoders and reset using encoders. Drive using encoders, 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 encoders. Okay, now I get down here and I see this method called white tape detected. ODS, that stands for optical distance sensor, so that, okay, they're using the optical distance sensor, let's go look at how they do it. So I hit Control, click, and now I'm in the program called PushBot Hardware Sensors, which was the parent that was extended. And here is the method that they created for detecting white tape. So the basic idea here was on PushBot, they were going to take one of the light sensors, which is the one with the two LEDs like this, point it down like that, and use it to detect the difference between light and dark so they can do a line follow. Okay? Or to just see if they got to a line. So here's the command right here. So I got all the way down, okay, well there's the command. This is how I check for whether or not there is light detected. But maybe I want to see something more, so I can Control, click. This takes me to all the way to the upper level. This is what's called an interface. Some of you guys I know don't know Java, but how many of you know if I'm talking about an interface in Java, what do I mean when I say interface? Does anybody know? No? James, do you know? No? Okay. An interface is at top level, I would describe it like a to-do list. So first created this interface they call light sensor. And for every kind of light sensor that's ever used, that class, they must have these methods. You notice there's nothing in these methods. These are just basically a list. It's like if your parents gave you a list, I'm going away tomorrow, I want you to do this, 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 and this. Okay, and they give you a list to do. And it's your job to go do those things. That's what an interface is. It's like a to-do list. So it says if anybody wants to create anything in light sensor, these are the things you must do. You must have a method called get light detected. And within that method, then you will put the code for your particular sensor and so on down. So I can come all the way up to this interface and I can see, okay, anything that's a light sensor should have at least these methods. It doesn't matter whether it's high-technic light sensor or modern robotics or anybody else. If they've implemented light sensor, I know I will have these methods available to me, which is helpful. Now the next thing is I want to go see, okay, who has implemented this? I want to see their code. So that's what Nick was showing you over here. I can click on these down arrows and I can go see where it was implemented. You guys might want to have to go there because this is all new for you too. You guys should probably be listening here also. So let's go see who implemented this interface. So I'm going to click over here on the eye. I can see it was implemented in two different places, high-technic and modern robotics. So that means I should be able to find two separate classes in here. One for high-technic sensors, which none of you guys are using, and then here's the modern robotics optical distance sensor. Okay, so these are both within the light sensor class. So I want to look at the modern robotics one, obviously, because that's the one we're using. So then I can pick that one. And here we are. So this now is the modern robotics analog optical distance sensor class. And it implements optical distance sensor. If I go look at that, it implements light sensor. So within this, I have all the methods for the modern robotics light sensor. I'm just going to call it light sensor. Optical distance sensor is a little bit too long.
ODS?
Hey, ODS or light sensor, okay? So within this are all the different methods. So I'm gonna scroll down. Okay, what are the methods that are here that are gonna be useful to me? Well, let's see. Get light detected. Obviously, that's gonna be important, right? That's the most important thing. I wanna get what light was detected. Then there's another one here called get light detected raw. Now this is the root command right here. This is the one that is saying from this particular sensor, which they defined up there as under the variable A, so they wouldn't have to type the whole thing all the way out again. They got tired of typing modern robotics analog optical distance sensor, so they just renamed it as A. So henceforth, they can just call it A. And we'll get analog input value, and B is the channel. You don't have to worry about all this. That's the wonderful thing. All you have to do is type in this method, get light detected. And what is it going to do? It's going to return a double value. That is the light detected. It's basically the raw value divided by 1023. Anybody have any idea why they divided by 1023? No? Or you have an idea? Sean, what do you think? Yeah, no, okay.
The amount of colors that it sees.
1023 is basically the max value you could get. So by dividing it by 1023, they normalized it, so your light detected is going to be on a range anywhere from 0 to 1. So if your get light detected, it returns a value of 1.00, what does that tell you? You just maxed out your light sensor, right? You're blinding the thing. It's not going to be able to read anything above 1.0, okay? So get light detected. So that's all that really matters to me at this point. I don't need to worry about all this. All I need to know is this method right here called get light detected. And anytime I want the light from my sensor, I just type in my sensor, put get light detected, and that'll give me the double. Let's see, what else is here for get light detected? I can enable or, well, theoretically, I should be able to enable or disable the LED. Now this is kind of a funny story. I saw from the interface that they have this method called enable or disable the LED, so I'm playing with it yesterday, and the LED was on, and it was kind of blinding out my color sensor. I thought, okay, well that's okay. I can just turn the LED off, right? Does anybody know anything funny about the LED command, the method?
It does nothing.
It does nothing. They have a blank method here, so I kept saying, LED true, LED false, turn the thing off. And it did nothing. Why? They have a blank method. So I finally called Modern Robotics and said, there's nothing here. They said, oh yeah, we haven't gotten around to that yet. That'll be in the next release. So here's the key thing across the board I've realized in the beta. A lot of the sensors have more capabilities than what we have available to us right now in the methods and classes that have been prepared. Now that doesn't mean you can't use it. What it means is that you don't have the nice interface already designed for you. If you want to take advantage of the full functionality, then you've got to go beyond the nice interface and learn how to program directly to the registers and commands and all that yourself, okay? So you can still do it, it just won't be as nice. And so right now, your LED is stuck on all the time. And last year, I was laughing, I was talking to Pirate Robotics, and they were telling me they were having problems with their color sensor, always giving them wacky numbers, and they couldn't figure out why. And they realized what they had done was they put their color sensor right next to the light sensor, and so of course the LED was stuck on all the time. So their color sensor was basically reading the always-on LED on the light sensor and giving them wacky readings. So be very careful when we get to color sensor, we'll talk about that. Be very careful about where you place your sensors on your robots, because there's LEDs on all the time here, right? Your power module, your control modules, they have LEDs on them. So be very careful about shielding and where you place them so that you're not getting overlap there. Okay, so that's just kind of showing you how to navigate around. So let's go back to my program, which is, there it is. Okay, so I'm going to start at the top with my program. Again, you guys don't have this one. We're going to type this in, but let me just talk you through it. You do have a print in front of you, so if you don't get it all typed in today, you can type it at home. So I start up here with all of the libraries that have to be brought in, which by the way, I'm just working in linear op mode here for now. It was fine. And so I'm just working linear op mode. So you have to import all these sensors, or all these libraries: color sensor, IR seeker, distance sensor, touch sensor, and gyro sensor. Obviously, there's not one yet for the range sensor, but these libraries will have all those methods and interfaces that I was just showing you. So you have to import those to be able to do it. Now, if you want to run one of them, we'll talk about when we get to range sensor. Okay, so let's move down here. Okay, extends linear op mode. This should all be very familiar to you. Very first thing I do here is declare the classes on all my sensors. So I'm declaring these classes right here were already defined for me. So I don't want to change the name on those. By declaring color sensor, then I'm basically saying, let me show you, control, click. This is the color sensor interface, like I showed you before. So all of these methods should be available to me. I can go see where and how they were implemented. Now for color sensor, you have three choices. Again, I'm going to look at the modern robotics color sensor. So this is where all of the color sensor methods are implemented. So by declaring my color sensor as a color sensor class, I have all of these methods available. I can see what we have here. I can return red, green, blue, alpha, which means white, and so on and so on. So I have all these methods available. So that's what I'm doing here. I'm declaring the class and I'm giving it a name. I'm calling it henceforth in my program RGB. That's my color sensor. ODS with optical distance and so on. So now I come down in my op mode and I need to do my hardware mapping. So you guys have already done that with your motors. It's no different. This is the name I want to call it. So I say henceforth, when you see RGB, that means color sensor, hardware mapped to this class. Go to the hardware map method and pull out of the config file what I have called MR. That was not the best, most intuitive name. I should have called it RGB. But anyway, so these are the names that you should have in your config file on your phone, or whatever you want to call it. You can call it whatever you want. If you've got multiple color sensors, maybe you might call it color 1, color 2, color 3. But you got to hardware map all of them and give them names. Okay? Now I'm going to, the first sensor I want to talk about is the touch sensor. So I'm going to scroll down and skip all this stuff and go to the touch sensor. I'm in the part of my linear op mode where I'm in the loop while op mode is active. So I'm going to come all the way down here to the section on touch sensor actions. The touch sensor is the most simple of all of them. There's really only one method you need. Is it pressed or is it not pressed? So this is how you would program in to collect the data from if your touch sensor is pressed. It will return a Boolean. I've called the value touch press. This is my variable. So it's going to go on my device that I call touch. It's going to call this method is pressed, which will go out to that class, and it'll read the register and tell me is it pressed or not. So henceforth, I have this variable called touch pressed, and it's going to be either true or false. That's pretty straightforward. Now what can I do with that? Well, anything. So let's imagine you put a touch sensor on the front of your push bot, and you're driving toward the wall, and you want to, what's that? Ouch. You're driving toward the wall and you want it to stop when it gets to the wall. That's very useful, right? This last year we had a beacon hanging on the wall. We wanted to maybe drive slowly until we touched the wall as opposed to bump it into the thing, okay? So you want to drive slowly. So I might put my drive routine inside the case, or the state machine, inside a while loop or an if loop, okay? Constantly checking, is it pressed? Is it pressed? Is it pressed? As long as it's false, keep driving, keep driving, keep driving. Oh, it's pressed, stop. Okay? That's all you have to do. So this is the only command you need for a touch sensor. So I can now take this variable right here, touch press, and I can use it in any kind of conditionals, ifs, whiles, anything I want to do with that. It's available to me. Now, I'm going to scroll all the way down and show you, I used it in telemetry. That's all I'm doing with it right now. So all I'm doing down here, all the way at the bottom, I have all these telemetry statements. So on my phone right now, when we run this program, you'll just see all this stuff printed out at the bottom so I can see the input coming back. So right here, I'm just basically saying print this variable touch press. And it's going to print either true or false to tell me whether or not it was pressed or not. And we test on the test board. I press a button, it goes to true, and if I release it, it goes to false. Okay? So that's about the most simple of all sensors. Does anybody have any questions about that one? Okay? Then Nick and Josh, while you guys were listening, I need you to get the device interface modules on these so we can hook up the test. Okay? So we've got 3. You don't actually have to connect it with bolts, just connect it with a cable and make sure it's added in the config files, okay?
Wait, are rolling?
Did you just take their sensors?
No.
Are these? Oh, these are our sensors, okay. All right, so I'm gonna highlight for you what I want you guys to type in. And so we're gonna start by you guys typing in what you need to type in for the touch sensor, and then you'll come download it and test it. All right, so what you can do is just go create, let's see, didn't you created a linear op today already, right? Yeah, didn't you guys create a linear op? Or was that yesterday?
No, yesterday was linear op.
Okay, so go take whatever linear op you created yesterday, copy and paste it, and basically erase everything down below where it says,
Copy paste the entire class.
Yeah.
or you could just start over if you
Linear
want.
template, here we go.
Okay, all the way down through here. I want you to type all the way down through here. So you could just start over if you wanted, or you could copy and paste the previous one. Forget about the comments, you don't need the comments. But we need to import this package for op modes. You need to type these in. These actually, you might not need, but go ahead and put them in. At one point, the example I was using, what it would do is for the color sensor, it would change the background of the phone to match the color it sends. I took those comments out because I didn't want to mess with them. But you need all these libraries here. Take it all the way down here. Call the class, whatever you want to call it here, and make sure you extend linear op mode. So get all those typed in. The only one that really matters off the bat right now is touch sensor. You can add the others later if you're trying to be really quick. The main library is touch sensor, DD log, and controller linear op mode.
So remind me, is touch sensor digital or analog?
It is digital. Actually, you can go on either, no, it is digital, sorry, the light screen. Yeah, the digital, or the touch is digital, yeah, which one? Yeah, and the color is like you see, and the light. We'll start with those and then we'll come back to color. You guys typed in that?
Yeah, I got it.
You got it already? Fantastic. Okay. All right, you guys scroll down a little bit? Remember, for now, since we're doing touch sensor, you can just put in the touch sensor library, and then of course you need linear op mode library. By the way, you'll notice when you type in these libraries, if it's a library that you never use, it goes gray. So these two aren't being used because I'm not changing the phone screen color and those. So if it's gray here, you don't have to type it in. In my sample program, we're not actually using it.
So what's the IRC you're calling?
Call it IR.
IR.
Yeah, here they are, right here. This is what I call
That,
everything.
those are the declarations, I wasn't sure what you call the hardware maps.
I think I tried to make it the same, except for the color sensor called MR, but you don't have one. So ODS, touch, IR, that's all you'll be able to put on there. Okay, I'm gonna scroll down a little bit. Does everybody have the libraries typed in? Can I move past the libraries?
I'm still working on
I
some
worked.
of
We
those.
were working on the. I was working on the Sanjak computer, so all the other things it got kept on that computer. So I don't really have it on this computer, so I have to like go all the way back.
Okay, you can wait on the color, IR, distance, and gyro, just put in this touch sensor library right now.
Can I get the top import?
Oh, that'd be the,
Yeah.
If it's gray, you don't need to worry about it. You want the package all the way at the top?
No, DBG log. Do we not anywhere?
If it's gray, you don't need to type it, it's not being used. It was,
Okay.
I probably should have deleted it. Since it's gray, it means that some of the. I'm just going to take it out. Now, if it's gray, don't type it.
Did all the other sensors type them?
For now, just type the touch sensor. Just type this one. You need linear op mode, and you need touch sensor. All of them you'll need, but to save time, you can move on. Bear in mind, this is all on the piece of paper you guys have right there that I handed out to you also. Yes. Yeah, just start. Yeah, you just start. Yeah. Okay, I'm gonna go ahead and scroll down and show you guys the next part. So under linear op, you wanna make sure you have these in. These are your designations. Make sure you don't rename it to something else, because these guys are up here setting up the config file with these names. So make sure that you're consistent and use these names so you can come test on these push bots.
Can you scroll just a little tiny bit?
If you need it, it's a little tiny bit, you got a piece of paper right here.
Oh, it's all in here?
It's all on there.
Okay.
That's the exact duplicate print of what we're going through right here. But you don't need to type in everything, we're trying to focus on the touch sensor, but go ahead and we're gonna get all the hardware maps in. So I'd like for you guys to type everything down to, well, don't worry about gyro, you won't be able to test gyro. Everything down to here, okay? You get everything in down to there, you'll have all the hardware maps in and ready to go.
From the top, do it all the way.
From the top all the way to that line right there. They'll have all your hardware maps for all the sensors. And even though you won't be able to test them all, you'll at least have them there. So when you buy them, because you're going to go buy them, you'll be able to use them. Do you have a copy of the program there, Nick? Yeah, if something comes up red, remember it means that there's an error. If the red is in the library, it probably just means that you dropped a word or you have a misspelling or something in there. one phone here. Where's the other phone?
Those are the robot controllers.
Yeah, where's the other phone?
Ours is right here.
The phone, is this your robot?
That's our robot.
Oh, okay. Where's the phone for this one?
But where's your guys' robot controller phone?
I plugged it up.
And where's the driver station?
Right there.
Yeah, this is the San Jack. We need the other San Jack phone.
Look at the sys board.
Okay, do you have both of them over there?
Yes.
For that one? Check and see if that's over there. Let's move this one down. Is it paired ready to go?
No. Well, this one's for 3333. It's robot 3333. We got 3333. That one is. Oh, this is the one that the launcher keeps saying the launcher has stopped. So this is the unusable one. This is the unusable one. Yeah.
Okay, well, where's the driver station? Did you turn this on?
Okay, here we go. These two go together. These two.
Fire it up to make sure everything's hot.
I just did. They're on.
Do we need to write in the comments?
It's all ready to go.
Have to. It'd be handy, but you don't have to.
Okay. All right, I'm going to show you the next important part. Okay. Does everybody have down through your hardware map? We're close to it? Okay. I guess I'll wait.
Okay, done with hardware map.
What's that?
Done with hardware map.
Okay, raise your hand if you're done with hardware map. Okay, most of you are done, so we'll move on. Okay, so remember right now, we're only concentrating on touch sensor. So the next thing you need, you're gonna type in below, let's see, where's your, okay, so if everybody's got this typed in here, right? Public void, run off mode, throws exception, you all have that? Yeah, okay. Then the next thing you need to make sure you type in is the wait for start right here. This is part of the basic linear off mode format, so type in your wait for start. And below wait for start, type in while off mode is active. We're getting the basic skeleton done here. So you want these two right here. Oops. Right there. You don't necessarily need the comments. Comments are just for my benefit. And your printout has all the comments, so you can just type the code, not the comments. So wait for start and while off mode is active. Okay, does everybody now wait for start and while upload is active? And Nick and Josh, you're probably gonna be needing to walk around and help everybody double check, make sure we've got plenty of curly brackets. Alright, so we're gonna come then, beneath the wait for start, you're going to type in this command right here. This is the only one you need for the touch what this is doing is it's declaring a variable called touch press. It's saying it's Boolean, which means it's either true or false. It's saying the value of touch pressed will be whatever gets returned when I call the method is pressed for the sensor I have called touch. And then the last one we want is telemetry, which let's see if I can get that on the screen too. Ooh, I think it's barely squeeze it on the screen. Can you see the is pressed all the way down at the bottom?
Touch pressed.
Okay, all right, so there's your touch sensor command up there, and then after that, I want you to type it down near the bottom, leave space, because we're gonna grow, put this telemetry command in. All this is gonna do is print to the phone. It's gonna, this is the string, it's gonna print 07 touch pressed, and then after it, it will print the value of this variable touch pressed. Josh, you might wanna kind of block it. It will print touch pressed, which is the Boolean that's returned up there. And let me explain, by the way, why I have numbers in front of this. Or maybe I'll let Joshua
I
explain
actually already
this.
explained it.
Oh, you did? Okay. Does everybody remember why we have numbers in front?
Just to label them.
Oh,
Yeah.
They list them.
Yes?
I don't know anything about programming, but I remember this one thing is so that they are in order.
Yeah, because otherwise what the telemetry does is it alphabetizes everything. It's so irritating. So if all I put was this, it would constantly reorganize and put it in alphabetical order. Well, maybe that's not the way I wanted it to be. So I have to put numbers in front of it to force the order. Now, unfortunately, I have so much here, you're going to find when we get to the end that it prints at the bottom and then it scrolls back on the top again, so it's no longer in pretty order anymore. But that's why I put the numbers. If you don't mind it alphabetizing, then don't worry about the numbers. It was just kind of frustrating. We were, why is it doing this way? We want this one on top and this one on the bottom.
Oh, yeah.
So you need that one and you need that one. If you have those two done and you have your curly brackets to close it, then you should be ready to come test and see if it will work with your touch sensor on PushBot. All this program is going to do is if you push the button, it'll print touch pressed true or false on your phone. That's all it's going to do. Okay? So go ahead and if you haven't finished, bring it over, download it, and test it.
Is that just after this?
You need to access the power. It's okay, it's fine. Russell, can you help us kind of move over this now more?
The other secret would be just,
Yep,
and there is,
we don't know if they get released.
because on any one person.
I know they sold it last year. So there's no guarantee, but
Program it.
I'm betting they will, so we're gonna go through that. Yes, is your touch sensor ready for test?
No.
Is that
Okay,
it?
work on that one. Work on the touch sensor. Yes.
It's not recognizing this as a.
That's because you misspelled it.
Oh.
Took pressed. If it shows up red, guys, check that you didn't leave something out or you didn't misspell it.
And now it's spelled correctly.
Okay, we'll go up. What did you call it up here?
Here, touch press.
Are you sure?
Yeah.
Boolean touch
Josh,
press.
is it okay if I just do a couple of them?
Yeah.
Because we're not using it.
It says that it is not a symbol. It resolves symbols.
Okay, you're gonna make
What it's looking for.
There's gotta be a typo here we're missing. Here, Josh, come help him troubleshoot. There's some typo we're
you're
missing
gonna
here.
do a,
He's declaring it as a Boolean. Let's see, you do have touch sensor up here.
we don't have it in a while op mode is active loop.
Oh, it should be. I had that highlighted. Yeah.
Okay.
Okay, let me back up. You guys need to make sure that your.
While op mode is active.
After this?
Yeah.
Where's the while op mode is active
Okay,
in?
hold on. I'm scrolling up there.
Line
You went
112.
too far. Stop. About to
There it is, right there. You guys need to make sure you have these. Wait for start and while off mode is active. Does everybody have those? After your hardware map, do you have those? Are you sure, Sean?
Positive.
Okay, good. Josh, help us troubleshoot.
that open, and then, okay, here, just put one more curly bracket.
Just right there.
Right there. Okay, so then inside the while
Yours working?
that's still to the right. Inside the curly bracket. While, go further right.
Good.
Yeah. Okay.
Hey, which configuration file did y'all use?
There should be a configuration file called like test, or not test. It should be in the currently active one.
Actually, the bottom one, I think.
What did you call it, Nick?
Yeah, I just edited the currently active one.
Add all the
If it comes up with
sensors?
something for the other over here, I think it's
Yeah.
pretty positive it's that one.
So, bottom section, and the telemetry,
Funny. Telemetry.
yeah. Telemetry dot data. And then that photo is so touch, press. Well, actually, it's a quotation mark. Touch, press.
Capitalized.
No, you don't have to capitalize it. So press. And then, after the quotation mark.
Did you find your error?
Comma.
Okay, pull up the print of the
Touch,
program.
press.
Josh is, he took it, so he can add it.
Yeah, there we go.
And he's
I was
back.
hoping to do that.
Straight down.
Gotta go with that.
This file?
Alright.
Yeah.
Where's the while?
Okay, James, is yours
So did that
ready
one?
to go, you think?
The green play button? And then, well, there's an
Oh,
arrow.
you're putting more in there.
Yeah, the IR instead of touch.
Why did it keep saying
My
that?
eyes jump.
Comment it for now. Yeah, just
It keeps
comment
going
because
to
you'll want
this
it
one.
shortly.
Well, I need it to say touch, not IR, so I have to erase it and change it.
Comment it, just copy it.
What I type, what I
Then you won't have
type.
to retype it. So you're gonna have to come back and put it in later. So I say just copy it,
Alright.
comment that one, but put it on.
Yeah, because I
But, you know, you just hit delete.
What I type, where I type, where I type. Alright.
So now,
I'll click where I type.
now he downloads it.
okay.
So whenever I press play, alright, I did the control slash file, and I did control slash find it where control slash.
The incompatible
Do I
apps
need that
version.
while
No,
all
it's missing the v4.jar. It means you have to go through Android Studio update.
Outside of it.
Oh, yes, that's the fun thing.
It's
Yeah, you have to do some
here.
update. You want somebody has to do the update here.
That, it's
That's like,
Oh.
yeah, that's not
the next day.
Find another one?
Okay.
Yeah,
Alright.
weren't there some that we already fought through this on yesterday?
Not this error. We have had zero yet.
Wow, this must have been a different.
Thank you very much, sir.
Mine still having some issues, because
There.
we just started loading up.
What's next?
Yeah, let's, you want to see if you can help us find another
Hey,
one that won't be in
what did
there?
y'all call?
Sure, I think almost.
Find it, Sean?
Yeah,
What's the problem?
I actually had this right here inside of the wow, inside of the wow. It's not supposed to.
You had it inside the,
Yeah,
Plug this one into the computer.
I had it
So you've
inside.
now joined me on this
Wow,
error,
not exactly.
which I have no idea like what the error is, but it doesn't actually really affect
well, it's
anything.
supposed to be inside the well.
So,
We do is just go to the OK ones. Okay, so it is
So
showing.
you should have wait for
disconnection.
start.
So just hit enter
If it's
twice
not
when
inside the
that's-
while loop is active, it's not going to continually loop. Yeah, see? Right here.
And then hit the third on that.
Very second. So while out mode is active, that's your first curly bracket. Well, the while out mode is active doesn't end until all the way down here. My second curly bracket doesn't until down here. So everything needs to be in here or it won't continually loop.
You could.
Are they letting them know where there's like two on top and some stacked on the bottom?
Wait a second.
Okay.
Okay, I had it a curly brackets in a curly bracket in the wrong place. Okay, now it's working.
Good, okay, well download it and go test it.
Okay.
So,
brackets.
No.
Josh.
This is autonomous, right?
I gave you guys some prints.
What am I end up on?
Most of it I want you to do. It's one thing to sit and be back, it's another connection. But you still have all of this to work with. Remember what it's supposed to be.
What's that?
Is yours working?
I had an extra color. It's because this is supposed to be inside the wow.
It's red. It's supposed to have 2 R's.
Yeah. Anyways, I fixed it.
Is it linear?
But the cool thing is if it's
Yeah.
red, yeah, you have 2 R's. If it's
So
red,
it's all on the right, the wrong
You gotta do that first.
did it work?
Oh, we were having more trouble with the configuration file, so.
We gotta add to the Optima register. Forgot to do that.
Oh, yeah, they have to add to the outlet register. That, yeah. Did you add it to your outlet register?
Well, he gave me, because I thought maybe it was something along my lines, so I called it out.
Oh, because you added in all of it.
Yeah, so I was just going to wait down there.
Excuse me?
Now I gotta add this back.
I'm hoping that tonight my dad
Open
will
it.
Yeah, just leave a comment in for now, and we're gonna gradually add everything piece by piece. So I was trying to get you, just do the touch sensor, and then we'll add in the next, and add in the next, by the time you're all
for my
set.
level.
But yes, hey guys, I forgot to tell you to add it into the out mode register before you download it. So you guys should remember how to do that, because we did that yesterday. If you need help, call Nick or Josh. So take whatever you're calling this class, put it in your out mode register.
That's gonna be the exact name of the protocol.
What's that? Nick or Josh? You guys are the programming team, you're kind of together. Nick or Josh?
Why don't we have our
Nick or Josh?
That good?
Josh or Nick?
I have no idea.
Just kind of.
So,
I need to get this.
Got yours
well,
working?
first go ahead and say
Yeah,
that.
it seems all good.
Okay. Remember to put it in the out
They
mode register?
don't, they took, they can be both.
You just say all.
why you couldn't leave.
No, one thing is,
You left? Oh, sorry.
Nick, is this the best way to say it? Say all?
They can be both.
Oh, you need to hit control.
Okay.
Somebody just
Had you
messed
reached
up
it?
on your computer. And please don't.
Now you get it.
Well,
Now
you
you can-
did, but you have your bag still in there.
they should have been on the.
Have your bag, open it on the floor.
So make sure you're next week you guys got a program. Nick, are we actually gonna work with them? Yeah, keep a copy of that offering. But of course now if you
So do you have the device interface module? Okay, yeah, we don't have an extra one.
Is this good?
Unfortunately, we don't. Like, well, yeah, we had a couple of them, but they're now hooked up to the other robots.
Oh, they are, okay.
Nick, are any of the phones free?
Any of the phones or any of the thrones?
Phones.
Phones. Yeah, that one right in front of you, right there. That one's free.
Yay!
Unless,
Unless.
yeah, they're using it.
Okay, never mind.
And
We're gonna test it out
this one
here real
ready?
quick, and then you can use it.
Okay. Whenever he is done, let
Okay,
me know.
guys, there's 2 push spots up here, so get yours tested.
I'm waiting
For what?
a phone. All the phones are in
Oh,
use.
that one to you? Okay.
Next week after they're done, I do.
Okay, let me do this. For those of you that are waiting, let's show you what to type next. The next one we are going to do, let's see, we'll take a vote. What do you want to do next? Light sensor or IR seeker?
IR.
IR.
IR?
IR.
IR is seeker?
You are what?
Raise your hand if you want to do IR next.
Which one is most beneficial to us?
They're all good.
IR.
Hasn't
chances are IR will.
Okay, we don't know if the IR beacon will be used or not this year. They don't use it every year. They didn't use it this last year. I was so sure they were gonna do it because they were selling the IR beacon on Andy Martin and the Tetrix page. So I was pretty sure we were gonna use it, but they didn't.
Why?
I don't know.
So
Maybe they
in-
thought we weren't ready for
In the
it.
clues that modern robotics have not given us, we know they're gonna be using the beacons.
Okay, yeah, let me clarify on that. That's actually, yeah, that was something, while you guys are waiting, I'll go ahead and tell you this real quick. Where's our beacon? So last year, we had these beacons as part of the challenge. Most of you guys, let's see, you were the only one that didn't do it last year, right? Everybody else in here is familiar with this, right? Oh, okay, well, he saw it though. Okay, so this is the beacon that was used last year. So the only thing they have told us is that they will be reusing these beacons, except there will be 4 of them. We have to change the programming somehow, but this is why everybody needs a color sensor, because enough to make you have an epileptic seizure. Okay, so the refs push the button on the back, and after you're totally blinded, it randomizes, and one side will go red and the other side will go blue. Now, we don't know what all they're gonna change, but obviously we're not changing out the LEDs, so we do know this much. There will still need to be having the capability to sense red and blue, and
Actually-
we'll do that with the color sensor.
Actually, the thing is, they did mention it's going to be a beacon reprogrammer, and if you look up in there, and if you kind of mess something up a little bit, actually I think it'll work if you pop the battery out and then pop it back in.
What are you trying to do?
You can actually see, it will actually go and flash different colors like that. The LEDs there are capable, they're full RGB LEDs, so they can do pretty
Give us
much
lots
any
of
color.
colors? Okay.
So the programming could be in any color.
Could be. Okay, so that leads us into one thing while you guys are testing. Well, we'll talk about it when we get to color sensor, but we're gonna learn how to use color sensor. And by the end of today, if we make progress here, you'll learn how to use your color sensor to sense the LED colors on here or the tape colors.
Let's do the light sensor because don't we have the different sides of the field? Like red and blue and then.
The light sensor is only for white or dark, and I guess if none of you guys have the color sensor, I'll be able to show you, but you guys won't be able to test it on yours. So we can type it in, but I'll have to show you, you won't be able to test it because you guys, we don't have color
And
sensors
red
for
and
you.
blue are both dark colors.
Yeah,
Something
okay,
else, yeah.
so, all right, we'll do color sensor. It's very
Yeah.
easy. Or not color, we'll do IR. It's very easy. No, we'll do light, but it's easier.
Yeah, let's do light.
Okay,
Can we change the colors of the light? I mean.
no, you cannot. Okay, the light sensor is also called optical distance sensor. If you guys have everything typed down through here already, you have all your hardware masks. Optical distance sensor, the only thing you need to type is, here it is. This is the only command you need for the light sensor. So type this command in down below your Boolean for the touch sensor.
I just tell me that. Probably not.
There you go. There, it's like there. I need to keep going. Yeah.
Wes, did you find the problem in your program?
Yeah,
there were the hardware maps.
Yeah. Mark, do we know what's wrong?
Somewhere, I pressed
If you're waiting, you can be tracking the light sensor stuff.
It's downloading.
Okay, wait, what's downloading?
The,
Uploading it.
yeah, I'm uploading it to the phone. They don't use their phones for it.
It's,
Nick and Wes, are you guys done with that one?
yes.
Almost.
Okay,
Trying to walk.
a lot of people waiting, move along. Those of you that are waiting, you can type in the light sensor. If you got the light sensor typed here, the next thing you would put in is your telemetry command. And I'll show you, it's all the way down.
Stop flipping water bottles.
Yeah, please stop that, guys, it's very distracting besides the noise. Here's the light sensor telemetry command, so you can go ahead and type that one in. You can put that one just above or below your touch sensor telemetry.
Why are you trying everything? Just let me do it. Take all this junk. Ready?
Is it working?
Compatible
Compatible version of what?
Average controller.
What?
That it became.
This is too updated, this is not.
I thought we had, oh, wait, we had this working yesterday. Oh, this is yours. Oh, okay.
They're programming to pay the same payment this is, so. This needs to be.
Okay, well,
Nick.
let's get it started updating.
Nick,
Yes.
which USB has the driver controller, driver station.apk?
Oh, you're saying this has
I don't
got
know.
the new one and they've got the old one?
Yes, this is the new version, this is the old version.
What do we do? But they're both ours.
When you guys get home, you need to update it.
I can update it right now.
Wait, hold on, but if their software isn't updated,
They're programming the same one that this is.
so you're, wait, what do you mean, current the same thing this is?
This is the same app as that. This is the first version of driver controller.
They had it working before, they had it working just a few minutes ago.
Yeah, it was working.
Impossible, possible on rollers. They're doing some weird stuff
They
recently.
had it working just, I mean, this is their robot and their phones, they had it running just a minute ago, right?
Let's, okay. Let's try yours.
Wait, Sean, is yours done and tested?
It's,
We're going to test it.
we were.
Okay, test it on that one. Test on that one. Don't press it on this. This,
It's not in use.
it wasn't.
Hold it.
Okay.
Just press it.
Get a touch sensor on the board on this.
So we press this.
Let me take a look at
Working, Wes?
Yeah.
Yay, got our first one working. Okay. All right. Anybody else ready to come test over here? Is your guys working?
Well, mine, I realize the problem now, but his, you gotta work, but anytime you press the sensor, it just kept telling you that it wasn't pressed.
Okay, do you have it inside the while up mode is active? Because if you've got it outside the while up mode is
He
active.
said,
Not easily.
we're connected to internet, so we can do
Nick, thank you for telling me about that whole Pokemon Go thing.
He did. What do you mean? I could just copy the text. Copy the text.
It's because now I can go catch a internet. No, I'm just kidding. I'll probably use it on something worth catching, like.
It only works on Android, not on iOS.
Oh, well then my plans are foiled.
Just get a ZTE.
Oh, I'm
20
using.
bucks.
This is my computer.
Yeah, I know.
Why are you?
I'm gonna take your program,
I don't
put it on that computer, upload it to
Yeah,
the
spit it out
phone,
when you're done.
so then you can use it.
How are you gonna get that program off of here?
Email.
No. No. No.
I'm gonna copy all this.
No. This is my computer.
Alright.
It's in the middle of the class, I just review by face.
Alright, is it done?
Yes, it's done downloading.
Yay, configuration.
Where did West disappear to? Anybody else want to try their program? Anybody?
Nick,
Yes.
this needs connecting to
Cool.
a phone. How? Connect, help.
They should be connected.
It's not, it says Wi-Fi disconnected, robot status null. Hi. Wi-Fi disconnected, robot status null. What the heck do I do? Thank you for being help.
I think I'm still
Yeah, I don't know why these are coming up red.
Oh, it's cool. Oh, yeah, where ODS? Because you only have touch sensor initialized up here. I figured out, so initialized.
Nick. Help me.
Okay, just a second. Hold on. Oh, well, for one thing, you have the robot controller on the driver station and robot controller mounts. Hold on. This is the driver station, but you have to install the robot controller on it. That's the actual robot controller. So, I have the driver station app now.
There's a small said that the
Really?
torch.
All day I'm laughing.
The key thing is the sensor, when you're plugging in the motor controllers, it's not like you're in the light. You have to actually take that port. So where if they plugged it in here at 4, it's 4. As far as I know, no one's got it.
What is this?
Okay, guys, one thing I need to point out here, on your device interface modules, when you're plugging in the sensors, the port number is important, okay? So, Nick and Josh. Nick, you're about to drive over all of these, and if you ruin them, we will have to pay for it, so please don't. Okay? So, if you have plugged in, this one, you put the, let's see, where's the touch? Touch is going into,
It's going into analog zero.
no, it's digital 0.
Yeah,
So
on
make
mine
sure-
it was set, it was in digital 0, but it was set to digital 7 configuration file.
Okay, so check the config file on this one. Is it set correctly? Is it in port 0?
Linear, this interface, digital, no, it's in digital 7.
Okay, yeah, that's why it was on the wrong port, on the config file. So your program is fine, it was just, come try it again. They're switching ports here. So everybody understand, that's really important, okay? The ports on this device interface module, they're all handed out. It really is important when you set it up on the configuration file that you match exactly where you plugged it in here. It's not just gonna find it and assign it for you. You have to make sure that the two are matched, okay? It works.
It works.
Yay, thanks. Okay.
I did just the touch sensor.
Yep, that's all we're doing for now, it's just touch sensor.
So I skipped it.
Yep,
Is that okay?
yes,
So,
yes, that's what it
hardware Mac, okay, so.
is. Josh, come help him so he can get caught up here. Anybody else need a test? No? Okay, then go ahead and make sure you can start typing in the light sensor stuff. Let me scroll down here again.
What should I have?
You should have that light sensor command typed in. And, oh wait, that's the telemetry, let me scroll.
Telemetry.
Do you have that telemetry pin typed in?
Which
And then all the way up here,
There should be while op mode is active, correct?
what?
There should be while op mode is
Yeah,
active.
these commands have to be inside the while op mode is active because that's effectively the looping part. If you put it after the wait for start but before while op mode is active, it's only gonna run once. That's okay if you only want it to run once, but if you want it to check your touch sensor repeatedly, then you gotta put it inside the loop so it'll continually check it as it loops.
What's the telemetry for the light sensor thingy?
The telemetry for the light sensor thingy.
Yes.
You have your printout there. Printout. It's this one right here.
That's really very
It's because we're switching.
What's that weird little symbol before the word? Like,
It's,
So
I don't know what symbol.
I have no idea what I typed there. I'll go see. I don't know what this symbol is. Some weird typo thing. It's a
I don't think that's
string.
even on our computer.
It's a percent symbol.
Oh, is that just the cursor?
No, that's a percent symbol.
It is? Okay.
Yeah.
It looks really weird.
I have no idea what that is. That's
He said it's a percent symbol.
Yeah,
It's your
percent
percent.
light detected.
Let's register.
That's weird though.
Yes, it is percent light detected. Okay, so let me explain here, guys. So remember I was telling you light detected is divided by 1023, so it's normalizing it on a scale of 0 to 1. In mine here, I multiplied it by 100. So if I multiply by 100, then what are we getting? Percent. So that's a percent symbol. So it's going to give you percent, anywhere from 0% to 100%. Okay? And it's a double, so it's going to give you decimal, so it could be 32 point blah, 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 blah.
So
Yeah.
you write that after a
I
while.
feel like
That's,
it's
well,
probably
put percent here, percent symbol to remind you that what it's actually giving you is percent light detected, 0%, 100%.
where is the light stuffies?
That's just saying that.
Where's the light what?
Light stuff.
Light stuff?
I just pointed it out to you. So not the
What do you need?
light, not the light telemetry, the other light stuff.
There's only one line for it. It's very, let's see, IR sensor, light sensor actions, right there, that's all you need.
Okay.
That's a one liner.
We got our phones.
Yours is the only one that has that on the back,
Double.
back end. Ours.
Double.
What was that?
What was that about Android?
Okay, while you guys are working on that, I will talk a little bit about the light sensor. That's my gray tile.
Great tile. Very good tile.
There it is. Oh, I know. Okay, so while you're waiting to test, let's talk a little bit about the light sensor. Okay, so when you get your light sensor on here, when you guys get your light sensor plugged in and you're testing it, remember what I was telling you about the LED would be on all the time? So, maybe I better wait, nobody's listening.
Can everybody get over here? Can I borrow flip?
If you have the phone in there first, you can have
Okay, did it work?
Oh, light sensor work. Capital D.
Your light sensor's working already. Cool, okay. Okay, so,
I test that?
let me have everybody's attention for a moment. Okay, if you're working on something else, pause it for a moment. I want to make sure everybody hears this. Let's talk about how the light sensor works. If you look at the front of the light sensor, there's two spaces here, okay? One is the LED, the other is the sensor. So it's gonna, as soon as it powers, it's gonna turn the LED on. Remember I told you a few minutes ago, you can't turn it off. You can't control it, it'll always be on. So this works on the basis of light reflection. So it's sending the light out, and it looks red by the way, it's sending the light out, and then it's calculating how much comes back. So let's talk about this. If I want to use it for, say, detecting to follow a white line, it would work really well, wouldn't it? Because which is going to reflect more light back? The gray fuzzy surface or the white tape?
White tape.
The white tape. Okay, so I should be able to, using this number that you have just set up here, this raw number, light detected, I should be able to do some logic on it. I pointed here, I should get something very low. It's going to depend on the lighting conditions you're in, obviously. Maybe I might get something around 10, okay, 10%. I'm over here, again, it's going to depend on your lighting conditions. I might get something higher, like 50 or 60. So I can make some logic decisions. If it's above 40 or 50, obviously I'm over the white light. If it's less than 40 or 50, I must be over the gray. And so I can make some logic decisions and drive my robot. If you see white, turn back to the left. Oh, now you're over gray. Turn back to the right. So you can do something like that to line follow. If you go to Google and look for line follow routines, there you can find pseudocode for line follow routines pretty easily. The most primitive one basically just kind of does a zigzag like this. So that if you've got your light sensor on the front of your robot, okay, pretend this is my robot, and I have my light sensor on the front right here. If it sees it's over gray, it turns to the right. Now it's over white, turn back to the left. So it's just going to go like this. It's going to go back and forth and basically follow an edge. Does everybody see that? So it's going to go like this. That's the most primitive. When you get comfortable doing that, you can do something a little less primitive. Maybe instead of sharp turns, you can do more of a gradual curve. Okay, so depending upon how much white you see or how long you've seen white, instead of doing a dramatic turn really sharply to the right, maybe you do a very gentle turn and then a very gentle turn back. So you're just slowly following it like that, okay? Now there's a couple of things, what you guys are going to need to do now that you know that you've got your data and it'll print to your phone, before you know how to use it in your program, you got to make sure you understand what the data is telling you. So you need to go home and play with this. Play with it into a couple of different lighting situations. What percent do I expect when I'm over the gray? What percent do I expect when I'm over the white? What if I'm in a very brightly lit room? Because sometimes you might be in a school that's got windows all around and lots of sunlight coming in. Does that affect my results? You got to know that, because if you program based on assuming you're going to see 10 and 30 and all of a sudden you get in a bright sunlight room, maybe it's 30 and 80, your program goes haywire. A couple of years ago when we were doing first LEGO League and they used a light sensor, not the same one but same concept on their robot, we found ourselves competing in this school, and in the auditorium they had lights all the way around. It was a beautiful, bright, sunny day. The sun was so stark coming in, the windows had the little pane dividers, and it was so bright that the pane dividers were casting shadows on the table, so it looked like black lines on the table and sent the colors or the light sensor completely into a tizzy. How can you avoid something like that? What might be something that you could do, Sean? Okay.
Limiting like the light, that's so like put it straight like below the robot so that the sunlight can reflect.
Exactly. One thing you have to think about is how much ambient light can be reflected in. So you can look at a couple of things. If you put it, hold on a second, under your robot near the middle, then it's probably going to be kind of shielded, right? Although just be careful again not to have it too close to any of these LEDs, because then your LEDs are going to be interfering. So these are the things you got to really think about when you're designing your robot. Where's the best place for my sensor? Now, if the challenge comes out this year and they have a white line, like this last year, we had a white line leading us up to the beacon, right? So if we had known how to use this, we could have line followed to line us perfectly up on that beacon to push that button, okay? So what could I do here to prevent an issue? I could, if I've got my light sensor all the way in the middle of the robot, it's shadowed, but it's also a little more difficult to control because the front of your robot is swinging out here and your light sensor is all the way back here. So it almost makes sense to have your light sensor in the front of your robot. So it's leading you, okay? But then you got to have something to shadow it. So you might want to consider some kind of shrouding or shielding or something like that.
Remember when we used the Batman cape?
Yeah, yes. On the Lego team, you were constrained. You had to use Lego parts, so we stole capes off of Lego minifigures and used the capes as little fabric shrouds around the light sensor. because I've got all this ambient light that's coming in and reflecting up. So if I can put a light shroud around it to prevent the reflection from coming in, then I've got more control over the only light coming back is what reflects back from the LED. Okay? So those are good things to consider. Now you may think, oh, well, I'll just build a little box around it. Well, here's another thing to consider. When you start playing with this, you're going to realize this is going to work best if you are no more than about 1 inch to 1.5 inches off the floor. Does anybody see a problem with that?
It's on track.
Yeah.
Start scraping.
You're going to start scraping. Think of if you had tried to go up the ramp this year with this thing down here. You would have knocked that off on that ramp in a heartbeat. So how are you going to handle that? What's that?
Sure will bit.
Yeah, you would have ripped it apart. So how might you handle that?
Go up the ramp the other direction.
Okay, you could go up the other way. Although then depending upon your angle, if it's sticking out the back, it might, you ever scraped your back bumper on a car if you're trying to go up? These are all things you have to consider in your design. So the bottom line in all this is when you sit down, or your mechanical people sit down to do the mechanical design, you, the programmers, have got to be involved because you need to put your 2 cents in for proper ways to incorporate the sensors, proper places, height, all that kind of stuff. And we can only do so much right now until we know what the challenge is going to be like this year. If we're just zipping around on the floor, no problem. We can have our sensors down there where they're close and accurate. But if we've got a 4-wheel drive up a ramp or over debris and all that again, it's going to take some thought on how to make sure if your sensor's up too far, you're not going to get a usable reading. On the other hand, if it's too close, you're not going to get a usable reading. There's a sweet spot.
Have a servo hook it up and down.
That's a possibility too, yeah. So that's where the fun part comes in. So they call it an optical distance sensor. That's a little bit of a misnomer. This does not give you distance. Literally, the only data that you're getting back from this light sensor is raw light detected. That's it, that's all you're getting. And because I was working on this yesterday and I called Modern Robotics and said, okay, I figured out how to get law right, but how do I get the distance? And he said, oh, we're not reporting distance. I said, but you called it an optical distance sensor, so I thought it was going to give me distance. He said, no, you are inferring distance based on the light that comes back. So let's suppose I've got my light sensor. Let's see, let's hold it up like this, okay? So I'm approaching an object. How much light's going to be reflected from back here? Not much. How much from here? They see what I'm saying? The closer I get, the more I'm going to see reflected. So basically what he's getting at is you're telling distance by watching this number increase. The higher it goes, the closer I am. Maybe. But then there's other factors to consider. What if I were trying to shine this at a clear water bottle? How much light would come back? Clear water bottle?
None.
What if it were a solid surface, but it were rounded? Such as, I'm looking for something. Okay, a cup like this. It's not transparent, it's opaque, but it's rounded. The light beam comes out and hits it. Some's going to reflect off that way, some's going to reflect off this way.
And it's also angled, so it's also going to go downward.
And some will go down. So
what
that's the
would
other thing to consider is when you're using this to detect light, this is a good point to go to Google and Google on the physics of light and remind that this is dealing on light reflection. So if it hits a flat surface and it's square on, you'll probably get most of it reflected back. If it's a round surface, a lot of it's going to reflect out. What if it's a fuzzy surface versus a smooth surface? Which will reflect more?
Smooth.
The smooth. What if it's a shiny surface or a matte surface? Shiny. See, all of these things you're going to have to take into consideration, and we won't know until they release the challenge. So when they release the challenge and you're thinking, okay, I want to use this to help me find the distance to the wall, okay? Well, will it help me find the distance to the wall? No, why not? What's the problem with the wall?
The walls are clear.
The walls are clear. It's not going to help me unless I can get it just perfectly to catch that little black strip at the top, right? Otherwise, it's not gonna help me find the distance to the wall.
And if your robot is too high, you roll over one of those little white balls.
Yeah, or if you're bumping up and down. So there are limitations. This will work great for a distance. It'll work perfectly if you're measuring distance to a flat, dark, or white object that's not moving, and it's got a, well, not matte surface, but not completely shiny surface. Okay, you see where I'm going? So there are limitations. It works really great though if you're aiming it down at the floor in that sweet spot of 1 inch to 1.5 inches to tell the difference between dark and light. Not so easy here. You can do it, but the difference, the contrast here or here even isn't as great as here. That's why on the floor this last year, this was the line leading up to the beacons. Okay? Now, could I use this to help me find something else? Like, let's say, remember this last year? The floor was divided in the middle with a red and a blue line, so during a time she couldn't cross. Could I use this to help me make sure I don't cross into the danger zone? Sure, I probably could. If you played with it enough to make sure that you were comfortable with the readings, so you knew exactly when you found the transition. And by the way, when you play with this, you'll see the light readings change a lot. They bounce around. So even if you hold it perfectly still and nothing's changing, if you look at your raw data, you'll see it has a lot of bump in it. There's a lot of noise. Where does all that noise come from? Anybody know? How can you have noise in light? I'm in a room. Nothing's changing. No? Noise in the light. What do you think?
Well, ambient light can cause that,
Well, I'm talking about noise. What would cause it to change? As I'm sitting here right now, if I were to hook this up and hold this right here static, and you were to see the number printed out on the phone, it's just constantly changing. Radio frequency? You're close. Yeah, she's getting warmer. What happens to these lights? They're all running off of 60 hertz electricity. And if our eyes could see that, we would see that they actually are cycling on a frequency of 60 hertz. Okay? So these sensors can sometimes pick up some of that because it's seeing the cycling in the light. In fact, there's a setting that you can set. It's either on this or the color sensor, I forget which one. If you're in Europe, you can change it to 50 hertz because most Europe places.
They said Altra is 60, US is 60, I think?
Yes.
And they're preset at 60.
They're preset at 60, so it won't affect us. But that is something to consider. That's why you see a little bit of a flicker, okay? So the light sensor works really great for some situations, not so great for the others. So you now know how to get the raw data, but you need to be very thoughtful about how to use that raw data effectively and intelligently, or else you're just going to be chasing your tail if you've got it too far up or you've got ambient light coming in. I still remember with the first LEGO League, the only way we could get their light sensor to work on one particular match is they had to stand like this and be a shadow to keep the sun from coming in and interfering. So they're having to move like this to shade the table so the light sensors wouldn't go crazy. You guys can't do that, so you have to plan for that. Okay, this is a very simple sensor, but again, understand your limitations. Any questions about the light sensor before we move on to the next one? Okay, let's move on to IR Seeker. All right, IR Seeker. Yes, absolutely. You can use these anywhere you want. If you use them effectively, absolutely. Okay, let's talk generally about the IR Seeker, and then I'll show you how to type it in. IR Seeker, okay. This was an IR beacon that I bought 2 years ago. I have no idea if they're going to use it this year. If they're going to use this one, we won't know anything until September, but it's great for testing, okay? This particular one is one of the ones that's on sale at, well, not on sale, it's for sale in Modern Robotics. There's 4 settings on the back. You can set it to either 600 hertz or 1200 hertz. I think 2 years ago when they used this, they told us which setting it was supposed to be. It can be 360 or 180. So you see each of these little branches coming out here? Okay, each of those releases an infrared light. So for example, if I turn this on and I'm gonna set it for, put my glasses on. I'm gonna set it for 60 hertz, 360, okay? You can see there's an LED on each side, so that tells me this side is now releasing, there's an infrared beam coming out here, here, and here, and on this side I have an infrared beam coming out here, here, and here. So theoretically, I could set this somewhere and I would have 6 infrared beams coming out. Okay? So the IR seeker will help you find one of those, and it's going to give you the angle and the intensity. So using that raw data, you should be able to somehow maybe find one and then follow it to approach that device where the IR beacon is coming out. Okay? So let's talk about how we would do that and what the data looks like. All right, so in the program here, you should already have your hardware mapping done. So let's come up to the top and show you. So again, you should have this library for IR seeker sensor, and then you should have this in your hardware map right here. So this is where I'm declaring the IR seeker, which, by the way, Joshua, did you guys call the sensors by these names in the config file?
Yes.
Okay. You guys, when your programs, you can call these whatever you want. Just make sure you're consistent with what you set in your config file and what you use here in the program. All right, so let's come down a little bit. What else we need for the IR? There's my hardware map. Oh, there was IR, okay. This is all I need for the IR sensor. Now, I'm not going to take you and show you the root class and methods because I took you there a couple of times. You got the general idea. If you want to dig down and see, you can do Control-click. There's only a few methods available to us right now in the IR, and these are it. So using this particular method that they've created, it will get angle. What that means is it will tell me the, so here's this device, it's got a beacon coming out. Let's say there's a beacon coming out right here, and I've got this IR seeker on my robot. What it's going to do is tell me what is the angle between where the robot is oriented right now and the angle of the beacon. So it kind of helps you to say, oh, I need to turn 45 degrees that way because the beacon is over there, or the beacon is over there. So it gives you an angle from the center line of the IR seeker to the beacon. And you can use that raw data to tell you how to turn to approach it. And then it'll give you strength. That's pretty straightforward. The closer you are, the stronger it's going to get, right? Within reason. Now, remember that getting closer means closer this way. So here's something else you're going to have to consider. Depending upon where they put the beacon, if we even use it this year, was not last year but the year before, the beacon was on those big, whatever they call them, the big ball dropper things. So the beacon was sitting about this high, would you say?
Yeah, one on
Okay.
each side.
On each side. So it was 3-ish feet off the floor, but your IR seeker is all the way down here in your robot. Okay, so bear in mind, you're going to have to consider that because that means the beacon or the beam is coming out and shooting off that way and you're down below it. The farther out it gets, it is going to spread a little bit, but you might want to angle up because as you get too close, if you're all the way over here, underneath it but real close to it, this location, you might not even sense it anymore. So you could see intensity increasing, and then there might be a sweet spot, and then all of a sudden it starts to decrease again. Because now you're getting closer, but you're getting below it so that the IR seeker isn't even oriented to see it anymore. It's just out of the field of vision now. Does that make sense? So that's another thing you'll have to consider as you're deciding where to place this, is you have to look at the challenge, where's the beacon? What height is it? The optimum thing to do is to try to get your IR seeker in line with the beacon. That would be optimum. If you can't do that, you might want to tilt it up a little bit. okay, and deal something like that. So these are the three commands. IR signal detected, this is a method that they created in there that basically has a threshold, basically the error threshold of the device. So what it's saying in this method, well, let me show you. Okay, so to find the method, I just control. Oops, went to the wrong place. Sorry, I went to the wrong place, clicked in the wrong place. Alright, let's try again. There we go. Okay, so this is the IR seeker sensor class. These are all the methods that they have available. These are all the methods they have available for us. Now this is the interface, so let me look at the signal detected and we'll go see how it's actually implemented. Again, I'm choosing modern robotics. All right, so here is our class for modern robotics. So basically, all this method signals detected is looking at is it's saying, look for this device, which by the way, again, they get tired of typing the whole thing out, so they just replace it with a letter. So they're saying, is it detected? Go get the strength. If the strength is greater than this certain threshold value, which was set up there, then just return a true. It's returning a Boolean. So true or false, is it or is it not above this threshold? Okay, that's all it's doing. Get angle, you can see all it's doing is it's going and reading. And here, by the way, I noticed this, and we'll have to ask, if they use 600 hertz instead of 1200 hertz, then we might need to change, because right now the only get angle method they have is actually pulling the channel for 1200 hertz. This seeker will give you 600 hertz and 1200 hertz both, but they're on different channels, and right now the only method they have is reading the 1200 channel. So that's something we'll have to watch for. But that's all it's doing, it's just reading the raw data, reporting it as a double, and returning it to you. So all you have to do is get angle. Let's see, get strength is down here. Okay, so again, they're reading the channel for the 1200 hertz and just giving you back the information. Now again, all of the sensors, or many of the sensors, have capabilities that might not be built into this class yet, but that doesn't mean you can't use it. It just means if you know Java well enough, or you can find someone that knows Java well enough, they can help you to create your own method to go access that particular channel. And how would you know what channel to go to? Well, that is why I gave you this document. So between this document and what you find on Modern Robotics, you can get the exact details. Let me show you, for example. Okay, I just opened it randomly here. This is the page for the gyro sensor, and it shows you every channel and what data is on that channel, okay, or address they're calling it. So,
I don't think we even got that.
oh, you guys didn't get one? Hold on. Let's see. Josh, we had 10 copies of this that you were handing out?
Yeah, that was already handed out.
They're all handed out?
No.
Okay.
Like two,
Here,
I
you
think
guys-
they're,
It's on the Modern Robotics page, so you can print it, but for the sake of today here.
I think we're all big bowl.
Okay. Do you want to look at it? No? Does anybody that's here for a team have multiple copies? Wes and Mark, do you guys have 2 copies of this?
No.
Do each of you have one of these?
Yeah.
Can you give one of yours to these guys?
Here.
Oh, yeah, okay, thanks.
It's easier for us to make another copy.
Okay. All right, so let's look at the one for light sensor, IR seeker, page 21. So look at page, Nick and Josh, you guys need to be listening to this too, because you gotta know this also. Okay, so be helping, but also be listening. All right, so page 21, notice what it's showing you here. The IR seeker is going to, when it reports in angles, you can have a negative angle. What does that mean? It means basically it's to the left. If you're getting a negative, that means your beam is to the left of the center line. If you're getting a positive, it's to the right of the center line. Now, I put plus or minus 20 here with a question mark. And the reason I put that was there was something buried in the programming somewhere that gave me a clue because I was trying to figure out, they didn't actually tell me what that range was, right? And somewhere, I forget exactly where, I saw 20 and I thought, is that why there's 20 there? So that's why there's a question mark. I'm not exactly sure if that's true. I don't know what is the maximum range that it has. So that's something we have to figure out. By the time I wanted to ask that question, my mother would like to go home. All right, so page 22, this shows all the addresses. So right now you can see for the signal strength, get strength, this one right here, you can see they're reading address 5 for signal strength for 1200 hertz. And then for direction, where's direction? For strength, where was that? Oh, that was strength, sorry. That was signal strength, direction was up there. So you get the point here. So you can still read the information for 600, but it just requires a different address. They haven't programmed a method for that yet, but you can make your own. Here's a model. You can copy and revise this, or maybe they'll update us from beta and they'll have all of those finished. Okay, any questions on IR Seeker?
I have a question, but it doesn't necessarily have to stay with the IR secret. Are you going to teach us how to make our own functions? Just define
How to make your own methods?
methods,
What time is it?
It's 3:08.
Ooh, I'd love to. I'm not sure we'll make it there today. That might have to be for the next one. But we could do that. We're supposed to have, when's our next workshop? It's supposed to be probably kickoff. Are you guys coming for kickoff?
Yes.
Okay. Should we do an advanced programming workshop at kickoff?
That mean a lot of people won't be able to be there, because of us, no.
Yeah, we just you guys. We could do that. We could do an advanced programming, teach you how to make your own methods. Because what would be really nice is if you guys can, this was my goal for these guys, and they're a little mad at me because I made them work over the summer. But our goal was to create our own methods. That's just what you're saying. So first of all, using the classes and methods that first provided for us to create our own unique error 404 for our robot. But now I'm discovering, as I dug into this yesterday, well wait a minute, I want to get the 600 hertz out of the IR Seeker. How do I do that? Now I'm realizing, unless somebody steps up and does it, we're going to have to create our own. So yeah, you're going to need to know how to create your own methods and classes. You probably already know.
Not only that-
I do?
One for the range,
I'll try. Let's keep going, see how far we can make it. All right, so, what else? Let me point out IR Seeker. Okay, that's later. Okay, so that's all the data we have for IR sensor for now. So we've done the 3 that should have come in your base kit, right? We've done the touch sensor, the ODS, which is not really giving you distance, so I'm just going to call it light sensor because that's all it really is, and the IR Seeker. So the next one we're going to do is the color sensor. So I know most of you probably don't have the color sensor, but you are going to want to get a color sensor. You're really going to want to get one. And let's talk a little bit about the color sensor. Let's talk about it in theory before we talk about it in practice. So, can you hook up my this thing for me again? Okay, so let's talk color sensor. My goodness, we still got to get through gyro. If I run a little late, will you guys shoot me?
Well, you know we can't because we're on a college campus.
Yes.
So,
Okay.
don't worry.
Color sensor.
God.
You know it's on over here. Okay, let's talk about the color sensor. On top of the color sensor, you see two dots. One is the LED, the other is the sensor. They say it is a true color sensor, full color. So it's releasing red, green, and blue. Okay, let's look at this one. Couple of tidbits I point out here that are very important. First of all, let me talk about active versus passive mode. You can turn, unlike the light sensor where the LED is always stuck on, for this one you actually can turn the LED on and off, and I'll show you the methods in a minute. And you want to do that, you need to do that. If I'm trying to read color on the mat, I'm not going to detect color unless I have some light reflecting back, right? Because that's what color is. It's light reflecting and coming into the receiving device. That's how we see white light, which has, everybody know what it is when I say Roy G. Biv? Yes. What is Roy G. Biv?
Red, green, blue?
Red, orange, yellow,
green,
the full spectrum, okay?
indigo.
Yeah. Oh, okay. So Roy G. Biv is the full rainbow, the full spectrum. White light, normal sunlight, has the full spectrum, Roy G. Biv. Fluorescent lights, however, do not have a full spectrum. If you could use a spectroscope on there, you wouldn't see a full rainbow like you see if you put a prism up to white light. You would just see very defined lines. It has only certain wavelengths. So what they've done in here is they've given you a full spectrum LED, meaning it gives you the full Roy G. Biv, and it's going to reflect off of this and then come back into the sensor. I think you guys aren't paying attention here. There's a quiz at the end of today, so you guys all need to pay attention.
I'm trying hard to ignore him.
So if I don't turn on the LED, there won't be any light reflecting to the sensor, and it's not going to detect the color. Okay? So it's what you call active mode. Turn on the LED, and then it's just like the light sensor. It's sending the light down, and it's measuring what comes back as reflected, except this time it breaks it into the different wavelengths, red, green, or blue, and we'll talk in a moment about how it translates that. Now then there's passive mode. When would I want to use passive mode? I'd use passive mode for something like the beacon. When I don't need to turn on an LED, I'm not reading reflected light, I'm reading generated light. So in this case, there's plenty of light coming off of this one, so I don't need to turn on the LED. I would be in passive mode and just point at it and read it. Okay? And by the way, it reads, again, the sweet spot for the color sensor is like the other light sensor. It's in the inch to inch and a half range. If you get back too far, it's not going to detect enough to give you a really good reading. You get too close and it's almost blocking it. So the sweet spot seems to be below 2 inches, but certainly not less than ½ inch. Okay? So you have two modes. You have passive and you have active. So you have to have the command to turn the LED on and off, which we do have, and I'll show you that in a moment. Now the other thing that they have pointed out is, strange as it may seem, you do not want to have your color sensor exactly perpendicular to your surface. Anybody have any ideas on why that would be the case? Sean?
Because the bulb that is sending out light is slightly off from the bulb or whatever
No?
that is receiving.
No? Not exactly. Any other ideas? What happens is you can actually overwhelm your sensor. And so as strange as this may seem, you actually want a little bit of it to reflect off. So the guy at Modern Robotics said they discovered in active mode when your LED is on, have it just a slight angle so that some of the light will actually reflect and miss your sensor. Sounds kind of strange. If it all comes in, you're going to find your sensor is going to get kind of white out, I guess. Is that the correct terminology? And I'll show you, they've got a diagram of what it looks like here. So we'll keep going. So the next page here, this shows all your channels. Now this is really interesting. These are addresses. There are lots of addresses with lots of functionality on the color sensor. So if you go to Modern Robotics, they tell you this is all the data you can get from your sensor. However, if you look at the modern, or the first class, right now there's only a few of these addresses that they've created methods to read. So right now, the only thing you can read is these 4 that I've outlined here: red, green, blue, and they call white, they call it alpha. I'm not sure exactly why, probably has some physics explanation, vocabulary, I'm not sure. So you can only read these 4 channels, that's all that's coming in right now. And then inside their method, they calculate something they call hue, which I'll show you in a minute. So there's all these other channels that you could read. For example, you could go straight to address 9, and they would give you color direct. In fact, if you go to the Modern Robotics website and watch their video tutorial, they show that they're reporting color. This is the address that they are displaying on their phone. And for red, it's about 3, and blue, it's about 10, or I might have the reverse. We don't have access to that address with the methods that we have available right now. You can create your own method and access it, but let's just look at what we do have.
Switch over.
What's that?
Switch over.
Yes, please. All right, so I'm going to come and show you. So we're not going to type anything just yet. I'm going to go through some of the color sensor stuff here. Okay, so let me just talk you through. Here's the same thing you've seen. I'm declaring my color sensor as part of the color sensor class. Here's my hardware map. All right, now there's a few things down here I need to do. First thing I want to do is I'm going to turn on my LED. This was just what they had in their example program. It's just nice. This enable LED method actually works. It's not an empty method like the one for the light sensor. That was kind of like, you know, the door buttons on the elevator. There's the myth that says those buttons don't actually work. All right, so they create an array here that they initially store at 0, and I'll show you why in a minute. And then they are storing some other variables here for the remote control. So what they're actually going to do in this sample program is it's set up so that when you press and hold the X button on your gamepad, it will enable the LED on your color sensor. When you release it, the LED will turn off. You can change that to be however you want in your custom programming for your robot, but for this sample, that's what they have. You have to press and hold it to get the LED to turn off, and then release, or to turn on and release to turn off, okay? So that's all this is doing. These initial variables right here are just setting you up to be able to monitor your gamepad. All right, so let's go down a little further. That's gyro stuff, we're ignoring. Color sensor, okay, here's our color sensor stuff right here. All right, so first thing it's doing is it's asking, what is the current state of my gamepad? In other words, is the button pressed or not? Store that under current state. And then we're going to come down and check to see if it transitioned. Did I push or did I release? So if the current state is true, means pressed, and the previous, it doesn't equal the previous state, then it means I am transitioning, and go ahead and set the previous state. So all of this is just around checking, did I press, did I release? That's what all that logic's related to, okay? So we'll come all the way down here, and basically it's either turning the LED on or turning it off. So I'll allow you to study that logic later, but that's what all this is about. Is it pressed? Is it released? Turn the LED off. All right, this is the next command that's of interest, so let's look at this one. For some reason, the Qualcomm and First guys decided that it would be better for us to work with the parameter called hue rather than color. So what they have done is they've taken in the channels that I showed you earlier, the channel that pulls red, green, blue, and they have created their own method that they convert red, green, blue to hue. Now what is hue? To explain that, let me show you. I went to Google. Not you, the other Google. He told me. So I went to Google and I looked up, yes, what was hue. Because I was getting confused. I would see one thing on the Modern Robotics website and I would see,
Press the green button on the remote. Okay.
this is really tiny. Here we go. This is what I found on the Modern Robotics website. They said, can you guys read that?
Yep.
Okay, they said these are the numbers that you would get, and based on these numbers, it would tell you what the color is. But remember what I showed you earlier? I don't have a method to read that address, so I can't go straight to color. Instead, first decided, well, instead of giving you color, we're going to give you hue. So they take all of that and they convert it to this. This came from Wikipedia. So this is color theory. It's called hue, saturation, and value model. So hue basically is what we would think of as color, okay? So it's a spectrum that goes around this way. And if you look at this one, again, this just came from Wikipedia. So in our case, we're printing out hue, a hue of 0 or 360, because it wraps all the way around in a circle, means red, and in the 240 range is a blue, okay? So again, be careful when you're reading this stuff on Modern Robotics, and remember that what Modern Robotics capabilities they've given you is not necessarily what Qualcomm has programmed for you now. You can do it. You can go access the channel for color, but if you want to use the methods, just a minute, Sean, the methods that Qualcomm has given you for now, you got to work with hue. So this would be the number that they are calculating right. Oh. So that's what they're calculating right here. They're calculating hue, which is, I'm not being an artist, I don't know why they're multiplying by 8, but all I know is they're taking these channels, multiplying by 8, and stored it in this array. And so now I come down here to my telemetry. And in my telemetry area, right, where's color sensor? Okay, so in telemetry, I'm printing these things. I'm printing alpha, which is raw data, that's what they call white. So I'm showing on the screen the raw addresses for white, red, green, blue, and hue. Okay? So I'm going to interpret those a little bit. If Sean has a question, yes?
It's not as much of a question as it is kind of a tip. What you can do is download just like a free image editing software.
Okay.
So basically a free version of Photoshop. GIMP is the one I use. And they actually have a hue thing similar, well, basically the exact same way that the other one does. So you can just slide on the little hue slider, or you can take a picture of whatever color you need.
Uh-huh. And it'll give you the hue number?
Just use
Okay.
the color picker option, pick that color,
Okay.
and you can look for the H value, and it'll
So
give you
how-
whatever hue value you need.
Whatever you need, okay? So how are you guys going to apply this? So this is the raw data that's all available to you right now. White, red, green, blue, and then again the hue. So let's talk about this. Red, green, and blue, that's pretty straightforward, right? If I have my sensor and I'm pointing it directly at the beacon, let's say that they stick with the red and blue colors and not do the other programming like Nick showed us. Well, it's pretty straightforward. If I point here at red, what would I expect to see right here? Green and blue will probably be pretty much 0. White will be pretty much 0, and I'll have a number for red. So if red is the greatest by a significant amount of any of these, well, I know I'm reading mostly red. What if I point here and blue is the biggest number and most of the others are mostly 0? Well, then I know I'm probably pointing at blue. Alternatively, I could go straight to the hue. From the chart over there I showed you, I know hue is either 0 or 360, and blue is about 240. So if I monitor this value, I'll see it be 240 and 0. 240, 0. Okay? So I can make judgments based on that. Let's suppose, like this last year's challenge, I came up and I needed to find the red side. I came up here with my color sensor. Oh, that says 240. Now I know I'm on the blue side, so what do I need to do? Turn on my servo that goes to the red side and then press the button. Okay, so that's how you could use that logic. Likewise, if I'm say trying to detect a line on the floor, I'm trying to find a red line or a blue line, then I could use the same thing. But again, you're gonna have to go test this, your sensor on your robot with your lighting conditions to see what values of each of these you would expect if you're coming back and forth trying to sense a red line over the top of gray. And what kind of numbers do you expect if you're over this red versus over this blue? I was actually pleasantly surprised when I played with it. You get a pretty good distinguishing number. It's pretty easy to detect. So if I'm pointing here straight at the red is definitely a lot stronger than any of the other numbers. So that's stands out. I can pretty easily recognize that I'm over the red. Let's talk briefly about what the white is. By the way, where did Nick go? Would you go find him? Because he needs to be hearing this too. Otherwise I'm gonna have to go through all this again for you guys later.
He's kind of disappeared.
Yeah, I know. He needs to be learning this too. All right, so what does the alpha mean, or white? Basically, that is the reflection. So glare might be another way to look at it. That makes more sense to me. And that's, what's that?
I looked it up, it's like transparency.
Well, yeah, but they're not using it like that. In their case, it's more like reflection. So this number would be really high if I'm getting glare. Let's think of an example. Think of times maybe if you're pointing your camera at something and the sun is coming in and you get that glare that kind of puts a white spot in or kind of fades out your picture. That's what can happen here if you get too much of the white light reflecting back in. And what can happen is, let's look here at the Modern Robotics. Oh. Can you flip me back?
Press.
Press a button that does a button that does another thing.
All right, so this is what the guy in Modern Robotics was telling me. If he was pointing at, say, a blue ball or something like that, he would be measuring up here like the Lego balls. He would get a 3 or a 4, no problem. But sometimes, if he didn't angle it just right and you got a lot of reflection, he would get a 15. See the difference? It's still blue, but now it's kind of like it's whiting out. It's becoming fuzzy. It's getting too much glare. But he found that if he tilted it just a little bit, like this, he didn't get as much of that glare and he didn't get the white out. So the lesson learned from that is, if you're going to mount your color sensor, don't mount it perfectly parallel to the surface you want to detect. Tilt it ever so slightly. And then you'll be less likely to get that glare that he's talking about. If you're in active mode, okay? Passive mode is not as important. Why would it not be as important in passive mode? Think about that for a second. Passive mode being when I'm trying to detect this without the LED. Why would it not matter? Yeah, what do you think?
Because in passive mode, they shine the light, they turn the light off, and then they'll get the results back without the light shining.
Yeah, passive, the light is already being generated and coming at me, so I already have all kinds of angles of light coming at me here, right? So I don't need to generate my own LED. So this only matters in active. And in active, if I have the LED on and I'm too close to my surface, then I have so much of my LED reflecting back up that that's where you get the white out. So tilt it just a little bit, you'll get some of it coming back and some of it going on past. Okay? Those are the things that you guys as the programmers are going to have to experiment with yourself before you can code your logic. So you don't want to just go code logic. If you see 240, stop. Well, maybe it might not be 240. Maybe it might be something a little different if you haven't angled it right or you've got the right reflection or something like that. So you're going to have to experiment with that. So let's look at our other, what else do we have here for color sensor? See, that's all the color sensor data. Yes, thank you. Let's go look at what they've given us in the, let's go look here. I'm going to go to the color sensor. This is the interface. Okay, guys, let me point out these two right here. You were asking if we could create our own methods to access those channels that we don't know how to access yet, that's what these methods would do right here, okay? We keep calling them channel, I should call it address. So basically what this one does is this is the one that sends a command out to an address that they haven't already created the method for us to do. This is one that would go get the data from an address that they haven't created a method for us. So if I want to get, what's the address for color? On the color sensor, look at your document and tell you, what's the address for color?
The color number or the index?
The color, oh, they have both color number and index?
Yeah.
I guess color number.
04 is color number.
0x04?
Yeah.
So you have to make sure you put the X's in, I think.
0x04.
So I could use this method right here, assuming that they've actually implemented it, to go get the data at that other address if somebody hasn't already created a method for it. So let's go look and see. So go here where it's implemented. Color sensor. And yep, they've implemented that set and get. Okay, so I could make my own method. I could call get color, and using this method that they created right here, I would call get I2C address, put in address 0x04, and it will return color. Okay, what's that?
The times 3 3s and there's so much.
3 3. Okay. Okay. Other important things to know about the color sensor. Yeah.
Yeah. X and capital B's.
Okay. There, the color sensor needs to be calibrated. You need to calibrate your color sensor on white and on black. Here's the tricky part. They haven't given us a method to do this calibration yet. So I can't show you in the color sensor class how you would do these commands. The capability exists on the sensor, but it doesn't exist in the class. So how would you do this? If you want to calibrate your sensor, how would you do it? You go back to that method that I just showed you, the set I2C address, and you would set I2C address of 42 or 43, and that would be how you would calibrate. Okay?
That's yours, right?
Yes, that would be ours, and the cable and everything. And the sensors too, I think, right?
Yes.
Okay? Just set them on the table.
Thank you for teaching us all about it.
You're welcome. Okay, so calibration. How would we do a calibration? This is going to be really important because what happens is they're going to go and set, let me back up a little bit and talk about the color sensor. Theoretically, the way the color sensor is designed, it's supposed to prevent it being affected by ambient light conditions. What the color sensor does is it takes a reading under the normal mode, like with the LED on, and then it turns the LED off and takes another reading. And it balances back and forth to 2 and subtracts. So if it's taking one with the LED on and one with the LED off and subtracts the 2, what are you getting there? What's the difference? The difference is what's being reflected by the LED. What is it subtracting out? Ambient light. Okay, does that make sense? So in theory, the color sensor should not be affected by ambient light. And you should go home and test it. I tinkered with it a little bit and I could see what they were doing. So I turned on the color sensor on active mode. I had it in a dark room and I got one reading. And then I turned the lights on in the room and the reading didn't change. And then I got a flashlight and I was shining the flashlight down and I was trying to mess it up. And I couldn't. As long as I had it tilted ever so slightly, right? Okay? If I had it straight on, I could white it out. But if I had it tilted like this, it subtracted out. It took into consideration the ambient conditions. So that's good. But this calibration is going to be important. And so we're going to need to create our own methods, since they haven't given it to us yet, on how to calibrate. So you can do it, the white calibration, you're going to want to point it at something. They say 3 sheets of pure white paper. Or black, you just point it off and space somewhere where it gets no reflection whatsoever. All right, so let's see. So So that's the key things on the color sensor. What else want to say? The color sensor. I think that's the good thing to have a color sensor. Do I have time to go through gyro, or are you guys tapped out? Anybody want to go through gyro, or should we stop?
I think we should at least discuss through gyro.
Okay.
Is the gyro on the sheet, like the programming for it and stuff?
The programming's on the sheet,
Okay.
but let me talk to you about the gyro.
Let's discuss it now.
Okay.
So you can discuss it, and then you guys can just look at the sheet that you guys have, and study that to see how you would program it.
Yeah, that's why I gave you the printout, so you can go, all right, gyro. Yeah, I'm talking a million miles an hour, I'm trying to get all this stuff in there.
Are you on talking a million miles an hour? I'll talk.
Okay, gyro. Modern Robotics has a great video on their website talking about the gyro. Basically, the gyro is going to give you rate of rotation around 3 axes, and it's going to integrate around the x-axis. So the x, or the z-axis, I'm sorry. The z-axis is the one perpendicular to your sensor like this, okay? So here's the idea. If you take your gyro and you mount it low to the ground preferably, but perfectly parallel with the ground, then as your robot turns, it's going to be able to tell you how much you have turned. Now it reports data in a couple of ways. You can do it in either Cartesian or what do they call it, not Cartesian, 0 to 360 degrees, or it can go negative and keep wrapping around. So for example, if I have it in the one setting, it would go 0 to 360 and then back to 0 and start over again. Or I could put it in the other setting where it'll go, if I go to the left, it'll go negative, minus 10, minus 90, minus 180, minus 360, and it keeps going, minus 720, minus blah, blah, blah. So you can actually keep track of how many times you've rotated. Or it'll be positive if I go the other way. Okay, let me show you the commands here. Okay. Let's come look at the... Thank you. Okay. A couple of things you have to do to get the gyro ready. We already talked about harbor map and all that. We'll skip all that. Harbor map. Blah, blah, blah. Okay, gyro preps. Here we go right here. I have a few things I need to do. I have some parameters I'm going to declare and initialize. Now, calibration. He talks about this a little bit on the website. The calibration of the gyro is very important. When you put your gyro on your robot, you're going to carry your robot up and you're going to set it down, and then you're going to calibrate it, and you are not going to touch it for about 30 seconds. Because it goes through, first of all, it has to warm up for a little while, and then when it's warmed up, then it'll do a calibration to tell it this is 0. So you cannot have it move at all, because if it's moving, it's not going to know where 0 is anymore, right? So it's got to be perfectly still. So this is the kind of thing you would want to do in your initialized portion of your program, right? The part that when you go up and you're getting your robot all ready and you press a knit, everything before the ref does his countdown. That's when you want to do it. You put it down, you don't touch it, you put it in exactly the position where you want it to be, and from that point on, the robot will always know this orientation is 0. So, let me draw over here on the whiteboard, for example. So, let's say I'm starting down here, and I put my robot here. My axis, I'll say this is my sensor. So this is 0. So I calibrate it, it's right here, it thinks this is 0 degrees, okay? Now as the robot starts to turn, let's say the robot turns and drives this way, now what is it going to read? Well, remember, this was 0, now I've moved maybe 45 degrees, so the gyro will probably read 45 degrees. On the other hand, if I moved this way, so I've moved 45 degrees that way. Okay? Depending on what kind of setting I choose, if I choose the one that it goes negative, it'll report this as negative 45. Or I can report the one that goes from 0 to 360. So what would this be? Well, if this was 0, then instead of 45, it would report this one. And what is that? 360 minus 45? Is that 315? Did it math correctly? Yep, 315. Okay? So if I'm set in this mode, that it's going to report everything is positive, this would be 45, this would be 315. And once I get all the way back to here again, that would be 360, and then it would start over again with 0. Does that make sense? Okay? So that's how the gyro is going to work. Now, this particular setting that I have in here is going 0 to 360, and it will not count the number of rotations. You guys are going to literally have to draw out and plan your moves. So for autonomous, I want to go here, and then I want to turn 45 degrees. So I would say turn until gyro equals 45. Now what if I come and now I want to go straight again? What would my gyro reading be now? What? It'd be back to 0 again, right? So now if I said turn until gyro equals 45 degrees, it'll do this. And now if I say turn until gyro equals 0, it'll turn back that way again. Okay? What if I say turn until gyro equals 315? What will it do? It'll turn to this orientation. But here's the thing about it that won't be so nice. What it'll do is it'll turn the robot around all the way that way. Yeah.
Why wouldn't?
Well, that's what you have to depend on. You have to decide which gyro setting you want to do. If you'd rather it just go E instead of E, then you have to choose a gyro setting that works in positive and negative. If you tell it go to 315, it's not going to find the shortest distance. It's going to go 0 to 315 degrees. Okay? So you might have a very long turn. So you're going to have to draw each of these out. You have to do some geometry here, map it out, and plot out, okay, from this one to this one, how much did I change? From this one to that one, how much did I change? And set your readings like that. All right, so let's come back here and look at back to Android's video. I'm still there. Okay, so that's what the calibration is going to do. So they have a sleep in here to wait while the calibration is completing. When the calibration is running, or when it's warming up, the LED will go solid. And then I think when it's calibrating, I think the LED turns off. I don't really remember. All right, let's come down. Where's our gyro sensor? Here we go. Gyro sensor actions. Okay. So this particular one is programmed so if both gamepad buttons are pressed, it's going to reset the heading. So the reset heading is equivalent to resetting coders on the motors. So what this one is saying here is if I press gamepad button A and B, I'm going to reset that value to 0. So it's a way that if I kind of get tired of trying to track my angles every time, just like you did with your motors, if you'd rather just reset it to 0 each time, then you can do that. But that'll be tricky. So say if I do this and go to 45 and then I say reset, well now that is 0. And I got to remember that now that is 0. Now what would it be to get from here to here? If it's 45, I might have to go negative 90 or 270 around, okay? So you have to really be careful. You really have to draw out and map very carefully when you're using the gyro. Use the reset very carefully because your 0 point will change every time if you reset it each time, and you have to just map it out so you keep track of where you're going and where you've been. Okay. Now, here's the raw data. I'm basically going to the gyro and I'm collecting raw X, Y, and Z. X, Y, and Z is giving you rate of rotation around each of the axes. What good would rate of rotation be? How might I be able to use rate of rotation?
how far you want the robot to turn before it goes a different?
Now, this is
direction?
rate of rotation, so it's telling me at what speed I am turning.
Yeah, how fast you're turning.
Maybe how fast I'm turning. I could use it as an indication of if I'm sitting still or if I am actually turning, something like that. I can tell you this, when I had this plugged in and the sensor was just sitting there, it wasn't even moving, it was just sitting there, and these numbers were constantly changing. So I would say, be very careful, play around with this and see how useful this raw data would really be. You might be able to use it, but just be very thoughtful about how you use it. Get heading, this is gonna be your best one, get heading, because that's gonna tell you how far are you from your 0 point. Yes, you got a question?
Well, it's a possible use for the rotation thing, and it's a completely impractical one, but it was really the only thing that came to mind.
What's that?
How many times you can spin around in a second, just to like figure out if you need to like spin multiple times to
You
get
try
a
it.
specific amount of points or something.
Try it.
I don't know.
You can see, okay, so right now, this is the only data that really appears to be of any use. Let's go look at the class real quick and see gyro sensor class. Theoretically, this is everything they were supposed to have available to us, but let's go see what's available. Oh yeah, there is a little command here, I forgot about this method, is calibration. This one's kind of nice, because what you can do, remember we had the whole issue with the resetting of encoders, and you gotta wait until it finishes, and you don't know how long it'll take, and blah, blah, blah. So they created a method here to check, is the calibration done? So what's nice is you can put your calibration in there, and right after that, you can have a while loop that basically says, stop right here and wait till you receive confirmation that the calibration is done. Okay, it's done, now you can move on. So that's kind of useful. So they have that one for us. Set heading mode. This is where you would determine, are you going to work in, let's flip to this real quick. Let's see. They tell us two kinds of headings. Where do they tell us that? Okay. Cartesian versus absolute, that's what they call it. So Cartesian is going basically through 0 to 360, absolute, negative infinity to positive infinity. I would think this one would be really confusing. What do you do if you're sitting there and you get a number that's negative 720 degrees? Yeah? So I would think this one would be really confusing. But, you know, if you want to keep track of how many times you've spun in a circle, you know, maybe the challenge is stand in the middle of the floor and spin around 5 times. I don't know, maybe it would be useful.
While carrying.
Yeah, who knows what they're gonna come up with. Okay, so let's come back here and look. What else do we have here? Here's the calibrate method. You set heading mode. So this is where you would determine, am I gonna be in the absolute or the Cartesian heading? Which do I prefer to work in? Negative infinity or 0 to 360? That's just your preference. Whatever you're going to start, you have to say, get heading. What else do we have here? Get rotation. This one's really useful. Look at that one. It gives you nothing. Because it's not supported. Raw, X, Y, and Z, literally, it's just reading from the addresses and giving you the raw data.
Hi.
So wait, is there literally a thing that just says not supported, just so they can say that?
Yes.
Why don't you just have a comment?
Yeah, they do. That's what the method not supported does.
Oh,
Somewhere in here is a method they created called not supported. And what it does is it prints to your phone a little comment that says, this method is not supported.
that seems kind of pointless.
I'm sorry, but we're taunting you with this.
No, they are preparing themselves for future additions,
Sure.
expansions. Remember, it was all new last year. They could only do so much. So they're,
Keep the stuff we can't use to themselves.
they wanted you to know what was yet to come.
Well, then make it to where it's not all these stuff.
Okay, that looks like that's all that's really useful on the gyro. Okay, so what are some things to be warned of on the gyro? Anybody ever played with a gyro before? Okay, what kind of things can, you know the gyro where you spin them and they kind of,
Oh, not
Okay.
those types.
what can cause a gyro to go wonky? Anybody know?
Sand in the mechanism.
Okay, well, keep it clean, okay. What else? Don't put sand in your gyro sensor.
Using it all the time and getting all the grease out.
Doesn't have grease. Actually, this particular one doesn't work like the spinning gyros. This has a little, it's piezoelectric, so it has a little piece that vibrates in an electric field in there. So
Oh, I
it's a
thought you
little
were asking
different.
about the little spinny one.
Well, I'm actually asking about this, but, okay, I'll just
No.
jump straight to the answer to run on.
I think.
Okay, what can cause your gyro to go wonky? Magnets.
That's another thing to get magnets.
Okay, now do you see a problem with that? Are there any magnets on a robot?
Or a single motor.
What?
Lots.
Lots.
Electric
Yeah,
motors.
it's all over the place.
Wires.
The EMS field around your motors. So he
Wires.
said, and your wires can generate a little EMS field. So he said, well, make sure you don't have your gyro near your robot, but by the way, keep it as low to the ground as possible. I'm like, "But your drivetrain's on the bottom. If I put my gyro down there, then it's right in the middle of 4 motors.
Gear train.
What did I say?
No, I just said gear train.
Oh, okay. So then I asked him, I said, well, is it susceptible to the electromagnetic field from the wires, the power wires? And he said, I don't know, we haven't checked that. So he said, basically, they gave me conflicting stories. They say, try to keep your gyro as low to the ground as possible, low on your chassis. Why would you want it low? Because if it's up here at the top of your robot, and your robot has a tendency to vibrate, or maybe it's not a real stiff robot, it's kind of a little bit, yeah, you know what I'm saying? Yeah, a little rickety, then your gyro is going to be sensing that. So maybe your robot's not going anywhere, but the top of your like our scissor lift from 2 years ago, it was very wibbly wobbly. The gyro would think it was moving somewhere when it's really not. So keep it low, but on the other hand, don't put it too close to your motors. I asked him, well, what does too close mean? He says, well, I don't know.
Within a couple feet.
So all that is to say, we are going to need to experiment with the gyro sensors, and hold on 1 second, please. We're going to have to experiment ourselves. You guys, the programmers, put your gyro on your robot, experiment with it, and see where can I put it and not see interference. Can I put it within 2 inches? So I need to be more like 6 inches away. There's going to be a sweet spot on your robot. I can't tell you exactly. It's going to depend on where your motors are. And if you've got DC motors down here for your drivetrain and one up here for some other mechanism, then you're going to have to find the sweet spot for that. So you're going to want to put it someplace where it's going to be as stable as possible and not interfering with EMF stuff. Another thing is you do want it to be near the center pivot point of your robot. Anybody know why that would be the case? Sean?
Because if it's not really in the center, it'll think it's turning a bit more than it actually is, or it
might.
can, or sometimes in really weird cases, it'll think it's not turning as much as it is.
So imagine, here's my robot again. Okay, let's say I have a 4-wheel drive. If I put my gyro right here in the middle and I do a perfect point turn, my gyro, the only thing it's going to see is rotation about that point. Very clean, very straightforward. What if I put my gyro out here? Now I have 2 things going on. As the robot rotates, it's translating. So if the robot moves to here, now my gyro has moved this way and it's spun a little bit. And so depending upon your movement, you could end up with a little bit of a misleading result. So the bottom line is having your gyro as near to your pivot point as possible is great. So if you were to set your robot up and do a point turn, that's the sweet spot for your gyro. You could put it somewhere else, but that's the sweet spot for it right there, because that would give you your cleanest and least confusing heading change. Sean, you had a comment?
Yeah, for keeping the gyro near the center but away from the motors, you could like have a little triangle system or something on your robot with 4 triangles on each corner, and then the motor at the top gearing it down to where the wheels actually are. That way
That's up for you guys
that
to design your particular, are we out of time?
yeah, we have 4 or 5-ish minutes.
4 or 5, okay. Let's see, what did I not go through? I went through, okay, so let's look at the telemetry for gyro. Oh, come back to mine. So what am I printing in the telemetry for the gyro? I am printing the raw rotation values and the heading. Again, I'm not really sure these raw rotation values will be of much use to me, other than just maybe as some kind of indication to tell me I'm not rattling, I don't know, we'll have to play with it and see how useful that data would be. What other sensors are available to you?
Anything you're gonna hook up to the,
Anything that works.
Okay, let's talk briefly about what is available in modern robotics. There is also a compass sensor available. We do not have a compass sensor. A compass sensor basically is going to, similar to a gyro, is going to give you heading, except in this case it's going to give you absolute heading relative to the magnetic field of the Earth. Does anybody see a problem with that?
Which way is north?
Well, that should change. But
Electric motors, man.
you got 4 robots zipping all over that field with servos and motors and wireless cell phones, and you've got so much electromagnetic interference. I would think, did you guys in any of your basic science classes do the thing where you put a compass near a wire and it goes? You didn't do that in any of your science classes?
No.
Oh my goodness, your school has cheated you. Go home and do that. Hook up a wire, a simple circuit, and put a compass near it, and your compass will just, it just freaks out because it doesn't know which way to orient itself. It is overpowered by the electromagnetic field of the wire, just a minute please, Sean, rather than the Earth's magnetic field. So, do people use a compass sensor? Yes, there are some teams that have successfully used it. How do they do it? Literally, they put it on a stick that is on some kind of a servo, and so as soon as it's legal, it goes beep, and they stick it way up high. So it's outside the noisy EMF field down here.
seems quite pointless.
Now, I've heard, I don't know, because nobody in our region used the compass, but I've read stories on the internet that some not so gracious teams would come in with, because they knew how to mess up a compass. You already know where I'm going, right? So what would they put on the top of a stick?
Oh no.
Something that would cause issues, electromagnetic. So don't do that, it's not graciously professional. Bottom line is, if you read through the forums, a lot of people have concluded a compass sensor is probably not worth your money. It's going to just drive you
It might be
nuts.
one of the ones in that bundle.
No, it's not.
It's not.
Yes.
If the person was on your team, your alliance, I could understand. Yeah, that's ungracious professionalism. But what if it's someone on the other team?
We'll
Is that
discuss
legal?
that another time. It's not gracious professionalism. Okay, the last one we need to talk about
It's just
is the range sensor. Let me talk about this one briefly. The range sensor I showed you guys earlier, it's a brand new one. I can't show you any methods or classes because there's nothing in the beta software for that. But can you use it? Absolutely you can. But once again, you'll need somebody who knows Java well enough to help you, because all you have to do is plug it directly into your device interface module, and then in Java, access that particular channel and that particular address and blah, blah, blah. So if you have someone that knows Java well enough, you can still access the data. It's pretty straightforward. Well, not that straightforward. You can do it. So range sensor is the new and upcoming sensor that we're recommending to everybody to get. Now, you're not limited to these. You can use anything from High-Technic. You can use Arduino sensors. At this point, you can use anything, Sean, please. You can use
Dex sensor.
anything, really. But outside these methods and classes that we've discussed here today, you have to program it yourself. So it all comes down to how well do you know Java and how motivated are you. You can use anything. Now, I don't know, I'm not clear on sensors in the phone, what is or is not legal, so I'm not even going to try to go there because I don't want to tell you guys something that might be wrong. So I would say, I know there are some sensors in the phone, but you need to look it up yourself to find out those are legal to use.
if you use the ZTE ones, there's not a lot of sensors that
No.
are useful, so I've looked into it.
Okay.
It doesn't even have a gyro, like,
They just put out something in the last, update
Proximity
this update
sensor.
saying they're adding the Moto G third generation and the Google Nexus 5 as phones
Oh,
to the
okay.
list, and they might have some more by September 20th.
Okay. Well, I had hoped that I could actually hook up the chessboard and show you guys the data coming out here, but we're out of time. So you've got your program here. You can go type this in. As long as your config file matches and you have the sensors, do it. You'll get the raw data on your phone. Play with the raw data. Become comfortable with what it's actually giving you, and then you can start to make decisions about how to use it appropriately. Phew. Okay. Hopefully you guys go home having learned something.
So yeah, the Nexus 5.
Is that good?
16 gigabytes of built-in storage is a 2.3 gigahertz
What's
processor.
the cost?
I'll look.
Because that Moto G second generation is like $149 a phone.
Google,
Are you all ready?
the Nexus 5 is $350.
So that's like a,
You say like 2.3 gigahertz processor, that's faster than your laptop.
Okay, so if you guys want to do advanced programming in another workshop, just say something to Sledge about it, and maybe either during the kickoff, or I think she's got some other workshops already on the plan, one in September and one in October, so we can possibly do some more there.
I think that's good. They always leave that down. Because they always use that when it's going to be used. I don't think they ever got here. Oh, was that? Yeah. Oh. I mean, you can just leave it like that. You have something back there?
it just brought up to put things back the way you had it.
Oh, no, yeah. That's a good thing to follow on that one and just.
You be careful too. I'll be in touch with you.
Yeah, just put all the sensors here, I got to sort ours out.
Where's your, Nick the drum guy?
Yeah, it's not up yet.
Okay.
Like I'm having, well, I guess they came first, so.
Yeah. I was like, thinking, I was like, you can't, you shouldn't terminate.
But it'll look
You
like,
can't do a voice.
at the earliest, it'll be up tomorrow.
What's that?